Hey everyone, welcome back to the channel. So in today's video, we are going to start a new crash course on LangChain. This will be the complete overview of the all the LangChain concepts. We'll be explaining each of the concepts with coding, okay? So that you'll get a practical idea of each of these concepts in detail. So there are a lot of concepts to cover in LangChain. So in today's video, basically we are going to discuss about chat models, messages, and chat history. So these are the basic building block of any framework that you use, any LLM framework that you use. So in LangChain, first let's start with the chat models first. Okay. So if we go here, so chat models are nothing but the LLM models that we'll be using. Okay, models I mean which are already pre-built, which knows how to generate a response, a text response given a user input in a text format. Okay, so LLMs are chat model which takes a message list as input and returns again returns a message as output only. So what are messages we are going to discuss next. So if you see, some of the features of chat models are, you know, they can integrate with any kind of chat models available out there, right? Like OpenAI is there, then Llama is there, Anthropic is there, right? And Google Vertex, Amazon Bedrock. These are the popular examples of chat models that are available in the market. So LangChain's chat model class supports integration with all of these. Okay, so in our case, we'll be using OpenAI model. Okay, I'll soon show you the code. Okay, about this. So if you see, there are a lot of chat models that it supports. If you go here, you'll get to know about a lot of chat models that is available here. So the second one is the chat models can take either LangChain's message format or OpenAI's format as input, okay, to generate text. Don't worry, when I'll be showing you the code, you'll get to know about this in detail. Next is three things that you are seeing: tool calling, API, structured output, and async programming, and all. These are the concepts which we'll cover in our second or third video. Okay, there I'll explain about this in detail. Okay, now let's just go to the next section. If you say about the integration, which we already discussed, it supports integration with multiple popular official models and some of the other, open source community based models also, which we saw in the list. Um, Now let's jump to the key methods that are available with the chat model. Okay, so if you see, it's good time to show you the code. Let's say here did nothing but I've just imported my API key which I need to use with the chat model. And if you see here, from LangChain chat models, I've uh, imported the chat OpenAI model because I am using OpenAI. I have an account with we have an account with OpenAI, and we have the API key for OpenAI, so I am using that. If you see, there are some parameters we are passing, okay, and initializing the OpenAI model class. Okay, this is the chat model, and then we are invoking that with a message of a user input, right, or human message or user input. So this is one of the method, that is the chat.invoke. If I run this, it's just saying some random silly lame joke. Okay, so some of the other methods available in a chat models are invoke, which we just saw, to invoke the model with the user input so that the output can be generated. And stream is nothing but, instead of waiting for the entire output to be generated at once, if you see, when I ran this, it waited to generate the entire output, then it gave everything at once. But when you stream it, what it will do on a token base, and token by token, it will give you the response so that you can stitch them together and show the output. Just like ChatGPT sends, right? When you type something, ChatGPT sends the output in a word by word manner, right? It doesn't just runs everything, then throws you the entire set of output at once. It just displays the output one by one. So that is called streaming. All right. Now batch is there is another method called batch. In batch method, what we do, you can actually invoke the model with multiple messages instead of just single message. You can pass multiple messages at once in a list format to for better processing and better parallel processing, for efficient processing. Then bind tools and structured output, as I told, we'll discuss about this in our tool calling video and video about tools. Okay. Now, as you discussed, input to a chat model is a list of messages either in the LangChain format or in the OpenAI format. If I show you the OpenAI format, this is the OpenAI format. Okay. Uh, Here it is not there. We will maybe see in the message. See. See, in OpenAI format, we send a JSON object where we mentioned a role and a content. Okay, but in LangChain format, this is something like this. I mean, we have inbuilt classes for it, right? So here we don't mention the role explicitly because role is inherent here. Human message means role is user here. Okay. So again, let's discuss that in the messages thing. So this is the OpenAI format and this is the LangChain format. All right. Okay. So there are some standard parameters that we pass when initializing a chat model, just like we have mentioned model, temperature, and OpenAI API key here. Similarly, there are other basic parameters. Model, we know the type of the model we want to use because ChatGPT has a lot of type of models, right? GPT 3.5 or Turbo, GPT-4, GPT-4o Mini. We are using GPT-4o Mini here. Okay. Now there is a temperature. Temperature means the level of creativity that you want the LLM model to have. If you pass it at 0, it won't do anything creative. It will just, whatever it has learned, it will just fetch information from there and just put it in your screen. But if you increase the temperature, it will try to be creative. Okay, just you can play around with this temperature value and you'll see the difference in output. Okay. Then there are other parameters like timeout, like how much time do you want to wait before LM generates a response. Okay. Then max tokens, the maximum number of tokens that we allow to send in the response, right? So these are the some of the parameters that are there. API we saw. So these are some of the parameters of a chat model. So that was about chat models. Okay, now let's just jump to the second concept of messages. So messages are very important. Okay, as we saw, chat models, messages are the input to our chat models, right? Just like we see here, this is our chat model and we are passing a message to the chat with through a invoke method, right? If you see, we are passing the list of messages here. So this is a chat model. This is a message. Now if you see, messages can be of basically three to four types of messages are there. Basically each message will have a role and a content in it. Okay, and some additional metadata which you can ignore for now, but role and content are important. Role means here the role of this message is user because or human, because this is a user input. So role of this message is a what? Nothing but user. Okay, so if you say there are four types of role possible for a given message, it can be a system message, it can be a user message, it can be assistant message, or it can be a tool message. Okay, we can ignore this function role, but in current scenario, these are the four types of messages that are being used or implemented. So system message is nothing but the message which sets the tone of your application. Okay, I mean sets the tone of your language model. For example, in the system message, what we can inform ki, hey LLM, you are a let's say cricket expert. Okay, or hey LLM, you are a research expert, or you are an expert about the Indian laws, or you are an expert about the stock market and financial reports. So this sets the tone or sets the direction. It gives a direction to the LLM model in what direction it will be thinking and generating the output. Okay, so typically this is optional. You can pass a system message. See, as you see, we have not passed any system message here. We have just passed a human message. The system message is optional. You don't need to pass it explicitly always, but passing it is a good practice. Next is a user message. User message, as you saw, is the user input that we are giving. You see, this is the user message that I have given. Okay, now assistant is the nothing but the output that the model has generated. Okay, this is basically known as a message in LangChain. Okay, so these are the different roles. So assistant message is the output generated by the chat model, and tool is nothing but the output of the tool call. Okay, tool call is in we can call external functions. Anyways, we are going to discuss about tool call in tool calls and tools in our tool calling video. For example, if I show you, just I'll give you overview. Okay, see, this is one tool. Okay, so we'll bind this to our chat model. Okay, then if you ask you what is what is 5 into 6 or what is 5 multiplied by 6, it will be able to answer you. So we won't go into that in detail right now. So yeah, if you see in LangChain term, there are 4 classes that are available, right? 4 classes that are available to prepare messages: system message, human message, AI message, and multimodality. So as we saw, system message, we already discussed about these types. Okay, and multimodality is nothing but the type of data. Let's say here I am passing just a text data, plain text data, but I can pass an image also, I can pass videos also, I can pass audios also. There are different types of data. Multimodal is multiple varieties of data, multiple types of data, multiple modes of data. That's what known as multimodality. So if you see here, as I told, AI message is the response from the model. Now if I just print the type, let's say let me print the type of the input message, and then we invoke the model with the input message, right? Then it generated the response. If I print both the type of both input and output message, you will see that, see, input message has a class of human message, and output is the type of the response. This response that I have received, it's a class of the AI message. Okay, so this is the format. So this is the format that LangChain supports. Okay, to pass as messages to our chat model. However, it also supports the OpenAI format. OpenAI format I already showed you, right? This is the OpenAI format. If you just pass this way also, I mean, instead of passing a object like this, if you just pass like this, pass this object, let's say, tell me a joke, it will still be able to answer your question. Just a second. I think here I've already mentioned error rate, so that's why it might not be taking. See, I passed input as a dict, but still it was able to generate some response from me for me, right? So you can either pass in a OpenAI format or pass in the LangChain format. Okay, so that is up to you. So this is nothing but a human message. Okay, I mean, if I give you an analogy, this is nothing but in LangChain it will be human message, then hello, how are you? Okay, now if you look at this message, this is nothing but the, in LangChain term, it is LangChain LangChain's constant context, it is I am doing well, thank you for asking, because the role is assistant. So in LangChain the roles are inherent. Okay, we do not mention explicitly because we have different classes for each role. I hope that is clear to you, right? Now we understood about system message, human message, then AI message. In AI message, however, there are two types of possibilities are there. So, okay, the output can either be a plain text. See here, the output of the model is just a plain text, right? Uh, of type AI message class, right? But the output can also be a tool call. Okay, as I saw. So the AI message output can either be a plain text message or it can be a tool call. All right. So if you see here, in tool calling, if you see, somewhere it is mentioned. Okay, see, let's say this is our chat model. This is our chat model actually. It is invoked with the plain text called hello world. In this case, the output, the type of this result will be obviously be AI message, but the content is just a plain text, right? Hello. Okay. But if I pass something like this to our chat model, which is bound, which has been binded with the tools, okay, above. If you invoke something like this, what is 2 multiplied by 3? Then the output won't be a simple plain string like this. Here it output is a hello. But in this case, if you print that result, it will print the result ka tool calls variable. You will be able to see some of these things like this. Okay, what is the name of the tool? What are the arguments that I am passing? What is the type? Okay, type of the message, whether it's a tool call or plain text. Okay, so that's what. So this tool calls is a property of the response, right? If you see here, the AI message. See, an AI message has the following attributes. So content, tool calls. So here we saw this is result of tool call has this format. Okay, if the question was about a if the question was supposed to be answered with a tool. There are other properties also, invalid tool calls, then ID, response metadata, and content. Okay, so in this case, if you see, the output of the model is plain content, right? It is a plain text. So result.content will be hello here. So this is how So this is how we prepare different types of messages. Okay, and invoke our chat models with user inputs. All right. So AI message is something that the model generates from its own. So we don't need to explicitly provide AI message. Okay, we will be explicitly providing human message to the input as the input. Now there is another type called AI message chunk, which is which supports streaming of messages as told. Instead of giving the output you at once, it will give you the chunks of the output in a continuous manner. You can then stitch the chunks together, okay, just like this. Then so the final response that has been generated by the AI model. Okay, yeah. So these are the some of the concepts about messages. And the next, now let's discuss about the next topic, that is chat history. Okay, so chat history, as you can see, it's simple. So it's just a history of chats. Okay, I mean the history can be something like this. Let's say this is message one. Uh, I'll create some other message called, I'll import, let's say, a message, and prepare something like, hello, I am Pritam. Hi Pritam, how can you, how can I help you? So in message 2 we can again ask it, what is my name? Now if you see, I'll pass this 3 messages as histories. Okay, I'm passing a list of messages. Okay, so that's why we are passing a list here. Okay, you can either pass a single message or you can pass a list of messages as chat history. So this is nothing but our chat history. Okay, that I prepared. If I ask this, uh, content is not defined. Sorry, I mistyped it here. Let me just run this. Let me just hide this for now. See, uh, when I invoked the model with history, okay, and the history contained my name, it was able to successfully understand that my name is Pritam. Okay. However, you don't need to provide this AI message. Okay, you can provide, but if you even if remove this and just invoke it with these 2 messages, 2 user messages, it will still be able to know that your name is Pritam. Okay. However, it's a best practice to maintain the sequence of response that has been generated in the chat history. So if you see, there are some guidelines to preserve the chat history. So as I showed you, I removed the AI messages. I removed the AI message from here, but still it was able to answer. But there are some guidelines. Okay, if you see, um, some key guidelines to managing chat history is the first message either be a user message or a system message, followed by a user and then an assistant message. Okay, so the first message, as you told, system message is optional, which is the first starting message of any chat model that you invoke. So it is optional although, but the next message will be a user message, and the upcoming and the following message should be a assistant or AI message. Okay, so the last message should either be a user message or a tool message. Okay, so see, these are not strict rules that you need to follow, but these are the key guidelines. I mean, if you follow it, it will be beneficial because here it is just simple, right? AI message has generated something, so some information which is not of that importance, but there will be cases where AI would have generated some important information for you, and you want to preserve that in the chat history. So that's why it is mentioned that you need to maintain the proper sequence, and the ordering has to be correct. You need to maintain a proper list of messages to act as a chat history. Okay, see, if you see, the chat history can be human message or AI message, or it can be something like human message, AI message, then some tool message, then AI message, and then a human message. So this is how chat history works. Okay, now there might be one question in your mind, ki how long should be the chat history? Okay, how big should be the chat history? See, every LLM has a limit on the number of characters it can process at once. Because even if you see in chat GPT, if you paste a long paragraph, right, which it doesn't support, let's say ChatGPT also has limit on its number of input tokens you can give it at once. If you paste a long paragraph, it will simply fail that number of characters has exceeded the limit, right? For example, if I just copy everything randomly and paste it multiple times, it is showing that message is too long. Okay, so that's what. So it's important for you to decide what should be the length of the length of your chat history. So based on your use case, you have to define the maximum length that it can go. I mean the maximum chunk size or the length of the chat history that you want to preserve, and pass it to the new message to act as the latest context for your LLM model. So yeah, that was about the three starting concept and three basic concepts of LLM. So I hope you understood about chat models and messages and chat history in details. So we discussed about three concepts of LangChain, that is chat models, messages, and chat history. And now we'll discuss about tools and tool calling. Okay, those are two important topics to understand, and how LLM, how tools basically, and how tools empowers LLM to do some tasks beyond their capacity. I mean, it just enables them with extra powers. Okay, in the form of tools, and they are able to perform a task with the help of these tools. Okay, so we'll directly understand about tools from the code directly. Let me just jump to the file. Okay, to a code file. So in this, I've just imported my keys and imported some libraries. Okay, from we are using OpenAI as our LLM. We're importing the tool also. So let me just import that. And yeah, if you see, a tool is nothing but a simple plain Python function. Okay, I mean it's just a decorated version of a Python function defined by this tool tool decorator that comes with this tools module from LangChain. And in this Python function, we have, as it is, the parameters and type of the output that it will provide. And we have a descriptor. Okay, we have descriptor string, and then we have the expression. Similarly, like this, we have defined these two tools. So as you can see, tools are only this much. There is nothing other thing fancy about tools. So this is what you see about tools. Now what we do here, we have imported our LLM model. Okay, then the model is bound with the tools here. Okay, we are using the bind tools method from this model, and then we are just passing a list of tools to it, so that the model is aware about these two tools. We are doing nothing but we are making the model aware that hey LLM model, you have the two tools available at your disposal: multiply and add. Okay, and if you see, I have deliberately you know uh, written wrong expression here. For in multiplication, I have written a plus b, and addition, I have written a into b. We'll see about that, why I have done that. Okay, now if you see, if I just invoke the model, right? We have this model. If I just invoke with a message like this, can you tell me what is 5 multiplied by 6 is? Okay, first let me just print the response here. Okay, if you print the response, you see we get a lot of things here. Okay, in the response we get content, then uh, some arguments we get the tool calls. Okay, lot of things we get, but out of this what we need is the tool calls that it has done. Okay, if you see, the content is empty here. Content is nothing but the output string that it has generated, and then we'll print, let's say, content and tool calls. Okay, if I print both of these, you see content is empty, that's why empty line got printed. And here if you see, it is provided a list of tools. Okay, list of tools in JSON format. Okay, that it is intending to call. Now if you see, it did not generate the output for me of, let's say, 5 into 6, that is 30. Okay, what it did, it in the tool call section, in the tool calls parameter of the response, it just generated uh, the the appropriate tools that can be used to respond to this answer. Okay, along with the, not only with the tool name, it also provided with the arguments. Okay, and the response type is obviously tool call. Okay, so here we see that LLM does not execute the functions by default. Okay, LLM is just, what, it's a just predictive model, right? It knows, given a given an input string or input text, it knows how to generate a relevant output in a textual format only, right? That's what LLM is all about. So you see, the input was a text string, and output is also in a textual format. So the main thing is, it did not execute this function to generate the output for me. Okay, so now you might be thinking, then how can we execute the tools and get the output then? So for that, we have to write some extra code. For example, each of this tool, right, when you define a function with this tool decorator, now this function becomes powered with the invoke tool. Okay, for example, if I show you, let me just add something here, multiplier dot invoke. If I do 5 into 3, 5 into 3, let's say, okay, and I just print it, it should, sorry, I think I need to, let me just go to the tools section and we'll see how to invoke these tools. Okay, okay, we have to give it in a string format. Okay, if I just invoke like this, you see it is able to generate the output because 2 and 3, but here in the expression I've written a plus b, that's why it took the input and it ran this function with this expression a plus b and it generated the output for me like this. Okay, so as all the tools have this invoke method with them, so now what we have to do in order to make this, okay, execute a tool and generate a response, what you have to do, you have to write some more code here. Okay, you see the output is a list here, right? So for e in response dot tool calls, if multiply, okay, so what we can do, we can actually invoke this tool. Okay, we have this tool here, multiply dot invoke with the entire thing. Okay, now if you just print it here, print r, it will print the response for me. Okay, now let's just run it once again. If I just print it like this, okay, response, I think I made some mistake here. So response dot tool calls, dict object is, oh, I think, sorry, do you have to pass like this because it is a dict, let's say. Okay, so if I pass the entire thing like this, I think even if I pass the entire t, it will run. Yeah, if you see, if t of name is multiply, what I did, I passed the entire tool object. Okay, this entire tool dict, I passed it to the multiply tool. I invoked it with the multiply tool, entire tool, this entire t object, then printed a response. And if you see, r.content has this answer, right, for me, that is 11. In the function I've defined it like a plus b, that's why it did 5 plus 6. So what, so the reason of making it a plus b is here that you can actually run your own logic. Okay, so whatever you define in your function, accordingly it will run and give you the output. Okay, so what we can do, actually we can create a new function for it. Okay, let's say execute tools, okay, which will take tools as parameter and run this for me. And print the response. Okay, now what we can do, we can actually simply do it like this, execute tools and, okay, now if I run this again, see it is able to run print the output. Okay, now let's, similarly we have another tool, right? We have another tool called add. So for that also you have to maybe elif add invoke t, then print r dot content. So actually you could pass t dot args also. I mean, you can, instead of passing the entire dictionary to it, you can just pass the arguments also here. You can pass it like this. Okay, and in that case what it will do, it will give you the output directly. If you print r, it will directly print you 11 here. You don't need to print r dot content. Okay, but as a standard practice, I'm just doing this. Okay, if I run this, Now let's just let it print the tool calls, and then we'll execute here. Now if you see for this example, can you tell me what 5 multiplies 6 is and 4 added with 6? So I am asking it to perform two calculations here, right? So if you see in the list also, in the tool calls list, it generated two objects for me, one for multiply and one for addition. Okay, and then it generated the output for me. Okay, 4 added with 5. I've written it like 4 into 5. That's why it gave me as 20. Okay. So now you understood how the tools are executed and how tools are defined, how tool calling is done, and how exactly tools are executed to generate an output. Okay, so that's about it. Now if you see here, let's just uh, see an interesting thing. But let's say I'm not passing any mathematical expression or anything to it. I'm just simply asking the model with how are you. Okay, if you see here, yeah, in the tools. Okay, in the tool section, see now if you see earlier the content was getting empty, right? When I printed response.content here in a few minutes back, it printed empty, and in the tool calls it it gave me this list of tools, right? But here if you see, for a simple question like this, the model was smart enough to determine that yeah, the output can be just a simple plain string. I don't need to give any tools, so the tools is a empty array now. And in the response content, I have something like I'm just a computer program, so I don't have feelings. Okay, some message it has given. So I hope you understood about the tools and how to perform the tool calling. So this is where we did the tool calling. Okay, so this is non. So till this part we have done tool calling. Okay, here we defined the tools here in this place, and then here we executed the tools. So that is all about tools and tool calling. Okay. So if you have any doubts, just put them in the comment section, and I'll try to answer your doubts. Okay. Now if we go here, just okay. Now let me just go to the documentation. Here you will see something about whatever they mentioned. We saw how to define the tools in tool decorator, and somewhere if you see passing the artifacts from one layer to another layer is a bit advanced topic. I'll create a separate video for this. So if you see here, there are some special type of annotations that we can use along with the tools. Okay, so for example, you can use these annotations for let's say injected tools argument. All annotations you can use, so that few things, let's say you want to few parameters you want to inject at the runtime. Okay, without the LLM exposing the schema. I mean, if you see here LLM exposes the schema, right? I mean, A is 5, B is 6, something like that. But there, in some cases, you don't want it to expose things like that. So, and you want to pass the parameter in the runtime. So for that, you can use here it is given the code also. Okay. Let's say user ID, I want to pass it dynamically. So I can just define the user ID's type as in injected tool arg. Okay. And it won't expose the schema in it. Okay. Now if you see for the next thing, we have something like runnable config. Okay. So what you can do, even if you have not defined anything specific to, I mean, for each parameter, you can actually pass a configuration object like this. Just like this is a very common practice, right? We can pass object in JavaScript also, in Python also. This is something similar to that. You can pass this runtime configuration. Okay, so for that you just have to define the key with this runnable config annotation. Okay, and you can pass any kind of dynamic value as you want. Okay, so these are some of the special annotations that you can use. Okay, injection state and injection store are bit advanced, and it is related to LangGraph. So we'll cover these two topics when we'll be discussing about LangGraph and state management and memories basically. So yeah, that was about tools and tool calling. If we go to tool calling, there is nothing much which we missed basically. Okay, you see all these things we already saw how to do it. Okay, you can go through the documentation. Okay, if you have get any doubts, just ask me in the comment section. We'll discuss there. Okay. We are going to discuss a very important concept of designing LLM agents, which is the memory, right? Because memory plays an integral part in designing, full-fledged agents, full-fledged LLM agents. Because without memory, LLM agent is nothing. If you just use LLM agent without any memory, it doesn't know how to remember your past message even. Let's say you put in one message, you ask one question that, hey, I am Pritam, and how is the weather in New Delhi today? So it will give you the answer like, hi Pritam, the temperature in New Delhi is this, right? But in the next prompt, if you ask, in the next message, if you ask, what is my name? It will simply say, I don't know your name, because LLM by default does not come with memory. It just knows how to process the input text and generate a response for that, right? So it is quite important to integrate memory when you are designing production grade agents, LLM agents, or agentic based applications for your company or for your product. So so for that, first let's just understand what are different type of memories that an LLM can have. Okay, so if you can see my screen, by default, on a broader sense, the memory of LLM is divided into two parts. Okay, the short term memory and the long term memory. As the name itself suggests, short term means will be just considering the most recent or some latest messages or latest interactions and using those as memory, while long term memory preserves the data and preserves the conversation and the output, that facts that has been generated from a conversation. It stores on a longer term basis, right? I mean, it is not just specific to one single chat session, right? It will keep on growing and you can reuse in future chat sessions also. So first, let's discuss about short memory in brief. So short-term memory, as you can see, lets your application remember previous interaction with a single thread of conversation. It's basically session specific. I mean, you are you are asking, let's say, ChatGPT something, it is answering you things, right? So that particular session, it will preserve the memory, and based on the previous interaction, just I mean most recent interactions and most recent messages, it will try to generate a response further, right? Let's just open ChatGPT once, okay? Now, if I ask something, what is the current temperature of New Delhi, right? So this is a single chat session I'm having with the ChatGPT here, right? So it is giving some information to me, and how will be the weather tomorrow, right? See, here I have not mentioned the location, but the chat is smart enough to understand that previously I asked about New Delhi, so this message also corresponds to this message only, New Delhi only, right? If I ask this question, it will again see the weather forecast for New Delhi. It automatically assumed that the place I'm referring is here New Delhi, right? So it clearly had the knowledge about its just recent interactions. So if you just keep on asking questions, it will best assume the location as New Delhi unless and until you specify explicitly a different location. So that's what the short-term memory looks like, right? But if I open a new chat session, let's say this chat session has ended, right? If I just open a new chat, how will be the tomorrow? So it is by default, taking a random location, Bhubaneswar. Okay. So as you see, it is not taking New Delhi because the chat session has the chat session is new. So the short-term memory is not preserved across chat sessions. So now just jump back to the documentation. So if you see here, so how do we use short-term memory in our conversation is to filter some of the message. Let's say we are having an interaction with the chatbot. This is a human message, this is the AI message. Then a list of chats and messages we are having, we are exchanging response with the chatbot. So one way to implement short-term memory is to have a filtered list. Okay, let's say you define that I will consider last 2 to 3 or last 5 messages, um, and then I'll utilize that to give the answer of the new query, right? Or give the answer of the new message. So this is one of the way you can edit the message list. You can filter the messages from the chat list and then use that chunk or list of messages as your current context to utilize it to answer your new user query. Okay, so that's how this is one way to implement short-term memory. So the second way to implement short-term memory in LangChain is LangChain or any kind of agent framework that you use. And the second way to implement short-term memory is to uh, summarize the past messages. Let's say I have a context window size of 5 messages, right? But before that, I can have n number of messages. But if I just focus on the last 5 messages, it is quite possible that I'll lose some important information which were there above that, right? For example, here I'm considering only 3 messages, but there could be some information, some useful information which are there above the context, above my current context window. So we don't want to lose this information. So what the second approach to implement short-term memory can be is key. No doubt you take this window of message, right? Window of 3 messages as your current context. Along with that, what you can do, you can have another window, right? Let's say 10 message or the entire history, let's say, but taking entire history is not practical because the history can be long. But you can have a defined set of number of messages to utilize as your second context window, and that second context window you can pass it to LLM. Okay, so if you see clearly, we are adding LLM layer which will be summarizing the messages for us. So the entire bigger chunk of conversation will be summarized to some few lines of information now, and you can utilize that summary along with your recent 2-3 message or recent context window to generate the answer for the new user query. So this is a quite effective approach to implement short-term memory in production, because here we are preserving the information which will be there in your older conversation. So without losing those information, we are now able to respond to the user query in a much efficient manner. But in the older way, we are just simply ignoring the message, which is not what we want, right? To lose information, because information is important. So this is about the short-term memory. These are two kinds of ways to implement short-term memory. So now let's just jump to long-term memory. Okay. Now long-term memory, as I told, it's not dependent on a single chat session. Just like we see here, as soon as I click on new chat, the session is getting, I mean, the session memory is not getting transferred to another chat session. So it's case of long-term memory. Long-term memory preserves the information from in a global state, so that it can be referenced, and the information in it can be utilized across multiple chat sessions. If you see, I am Preetham. Now if I click, see, it is storing the information in a separate memory. Okay, this is the global memory. Now this information is preserved here. Okay, I mean, if I open a new chat session, if I open a new chat session and say I am 26 years old, what it will do, it will store this fact in its memory. See, memory updated is saying, if I click on manage memory, see, this was from my previous chat and this is from my current chat. So it is preserving the information in a global state, right? So that the same can be utilized across multiple chats. Now if I ask, what is my name? It will clearly simply say your name is Pritham, because it is getting those information from this memory. But if I delete this, let's say I delete this memory and open a new chat session and ask, what is my name? It will clearly say you have not said your name with me. So you can now see the difference, how well long-term memory looks like. But it is not all. Long-term memory is actually divided into 3 types of subcategories. Actually, the 3 type of categories about long-term memory has been taken from this research paper. There is a very good research paper for cognitive architecture for language agent, where they are defining a new architecture to build LLM agents. Coming about the long-term memory, yeah. So from in this research paper, they have mentioned long-term memories as episodic, semantic, and procedural. These are the 3 main categories of long-term memories. Now let's just understand what are these categories and how it is important for you to understand the difference, so that accordingly you can design your long-term memory components, okay, based on these concepts. Okay, now as you see, a long-term memory, as we discussed, it is defined into 3 parts. It's semantic, episodic, and procedural. So let me just give you one example of all of each one of these. So in semantic memory, what it is like, these are the raw facts or static data which won't change. For example, if I say like if let's say I'm a travel agent and someone asks me that what are the places to visit in let's say Bangalore. Okay, from my knowledge, I can tell them that you can visit ISKCON temple, or you can visit Rameswaram, or you can visit to Hampi, right? From Bangalore, you can take the train. So these are the raw facts which is not going to change, right? These are the popular travel places, so tourist places. So I can suggest them this information. So the facts are actually semantic memories or static data which does not generally change. Now let's discuss about the episodic manner. Episodic memory. In episodic memory, what we do is episodic memories are linked with the previous conversation with the agent or previous interactions with the agent. Okay. For example, if someone now still I am a travel agent. Okay, if someone comes and tells me, ki, hey Pritam, last time when I visited Bangalore, you had suggested me to go to ISKCON temple. Can you suggest me some more places? You had suggested me to go to ISKCON temple, and which I liked. So can you suggest me some more places to visit? So from this, I can infer that the person is liking to visit temples, right? Because ISKCON temple I had suggested, he went and he visited it and he liked it. So next, what I can based on this current information, what I can suggest him, ki, yeah, now you can go to maybe Chikballapur, right? The Adi Yogi statue you can visit, because it's again related to that related to culture and all. So it's a temple also. So I can infer from it that he might be liking temple. So let me suggest a temple instead of suggesting him to go to any beach or kind of any bar or club, right? Um, so that's what episodic memory is about, right? It's based on your experience. Okay, I mean based on your past agent actions, like whatever actions I had done in past as a travel agent, I had suggested him to go to ISKCON temple. Now based on that information with my mind, I'm suggesting places for him. So this is about the episodic memory. So you can clearly see the difference between a semantic and episodic memory by now, I guess. Before jumping to procedural memory, let me just show you how semantic memory is in a agentic workflow. This is just a raw example I gave, but in a LLM agent point of view, let's say you are maintaining the profiles, right? You are storing the data, just like ChatGPT stored my name and age. Similarly, the LLM model is storing information about me. First, I told it my name is Pritam. Next time, telling it my name is what? My age is 26. So based on this conversation, right? I am having a conversation. I have a old memory, right? I have a old state with it, right? So in the old state, now with the new information that my age is 26, what LLM can do, it can update the information in the semantic memory. Okay. So this is how the semantic memory, it's just plain fact, a static data which won't change. My name won't change, right? My name is Pritham, it won't change. So it's a static data which it can store. Now to implement semantic memory, you can utilize in-memory stores. LangChain provides in-memory stores, right? Or you can consider using any external database also, right? So that is up to you how you want to store the data. But let's just understand the concept for now. Now, if I go to episodic memory, so one popular example of episodic memory is few short example prompting. Just like I gave you that example, right? Based on the some past example, I had suggested him to go to ISKCON temple. This acts as a example for me, right? This is a few, let's say one short example. I have one example with me to suggest next place to the same tourist or same user or the same tourist, right? So few short example, I'll definitely create a different video about few short example and how it is different from zero short and one short and few short examples, how they work actually, and how the output accuracy improves with few short examples. I'll create a video next in 1 or 2 days. So don't forget to check that out. So few short example is a popular example of episodic memory. Okay, because we are referring to some relevant examples, past examples, then utilizing it in the current context to respond to the user query. Now let's jump to the procedural memory. So procedural memory is kind of it's a defined set of rules, a defined set of actions, how you want to perform to get a task done, right? If you see here, by definition, it is procedural memory is nothing but the rules to perform task. Okay. So for AI agents, procedural memory is a combination of model weights, agent code, and agent's prompt. Basically, agent code we must be having, then we do prompting, right? And model weights is nothing but our LLM model that we are using. So This is about the procedural memory. I mean, it's just plain instruction. In few use cases, you might want to store the path it had taken to solve a given problem. Okay, for example, to let's say one user came to you and asked you to plan a trip to Bangalore, plan a trip to New Delhi from let's say Bhubaneswar. Okay, so to solve this user query, there are multiple steps involved. You want to design itinerary, right? Then you want to search the cheapest flight, then search the hotels for the user, then search the places to visit which he can visit. So in order to prepare the complete itinerary, it has to solve multiple problems. So what we can do, we can store this entire procedure that it had followed, like the book flight, then search hotels, then explore places and suggest places. The output of each of these steps we can actually store in the memory, so that next time if another user comes and asks, uh, give me a tour plan from Bhubaneswar to New Delhi for 2 days or 3 days. So what we can do, instead of regenerating the outputs again, we can utilize that memory and then refine the output a bit to match to the user query and reply to the user. So this is what the procedural memory is about. So I hope I was able to clear your concepts about episodic memory, semantic memory, and procedural memory. So all these three types of memory are actually long-term memories, which can preserve, which can be utilized across chat sessions. It is not dependent on the single chat session. So I'll suggest you to go through this research paper. If you like, I'll just put the link in the description box. And mainly this documentation of LangChain to understand about memory. It is explained in a beautiful manner about how to implement short-term memories. Okay, how to implement semantic memory, how to implement procedural memory in LangChain framework, obviously. So, but it will give you a gist of these things and its practical implementation. We are going to discuss about four more concepts. So in the previous section and the previous video, we discussed about chat models, messages, chat history, tools, tool calling, and also memories. So now we'll discuss about four more concepts: structured output, multimodality, runnable interface, and streaming. That too with code examples. Okay. So first, let's start with the structured output concept first. So as the name suggests, structured output means structuring the output of the LLM, or defining the structure in which it should generate an output for us. So by default, what an LLM does, given a input query or input string, it just generates the output in a text format or in a paragraph format, right? So what we can do is, using this structured output concept, we can actually direct the LLM to generate the output in a defined structure or defined schema. Okay, so you can define the schema like this using a JSON or using a pydantic class like this. Okay, and it will give you the answer in a desired section and in the desired manner. So let's not go through this documentation. Let's directly jump to the code first. Okay, so if we go here, let me first just import my key. I've imported the key, and here we are using GPT-4o mini OpenAI model. All right, I have imported the model also. Now if you see, if we don't provide any structured output schema to it, the model will generate a plain output in a string format. For example, if I just directly invoke the model with the query, okay, this is the model and this is where I am invoking it. If I just run this, it will take some time to generate output. If you see, it has generated a entire paragraph for us, okay, in the content section, if you see. All right, but what I want is, I want the LLM to generate an output in my own defined schema, because there will be a lot of cases where you want the output to be in a structured format, in a structured manner, in a key value pair manner, so that you can reuse that output in your further layer of your application, right? Just like you exchange JSON in your APIs, it's similar to that. So what we'll do, we'll first define a schema. So here I have defined a pydantic class, okay? Pydantic class I have defined, and I have my class is two keys. One is the answer and the follow-up question. Answer is nothing but the answer to the user's question, And follow-up question is a follow-up question that a user could ask. So LLM will think on its own and generate a question for us and give us in the output. Now what I am doing, I am using the with structured output method of this model. Okay, then I am passing the schema or the response formatter, this identity class I am passing to it. So now my model, LLM model, is aware about the desired schema that I want it to generate the output. Okay, now if we run this, now you'll see. Now instead of model, we'll use model with structure. If I run this, you'll see one thing. Let it run. It is running still. Now if you see, the output has only two things. Okay, one is the answer section. Okay, this is the answer, and the second one is the follow-up question. Okay, what are some of the Virat Kohli's record in cricket? So this is how we can structure the output and format the output according to our own will and our own defined schema. So LLM will do that for us. Okay, so that was about structured output, nothing else. Let's not drag it further. Okay, it's a very simple concept. You can go through the documentation for different type of other way to define the schema, just like using a JSON. Okay, all those things you can explore. So it's pretty simple. Okay, now let's just quickly jump to the next section of multimodality. Now multimodality means multiple types of modes of data. Okay, different types of data, modes or types of data. That means audio, image, text. Currently we have seen till now ki LLM, till now we have used LLMs with text based data, right, textual data. But LLMs are have become more powerful right now. They can deal with audio data, image data, PDFs also different kinds of data it can support. So it's known as multimodality. However, not all the chat models that are available, they support multimodality. Okay, for example, OpenAI supports multimodality. Gemini has its model, it supports multimodality. So you can see here, you can find which model supports multimodality. Okay, for example, Mistral AI, Fireworks, they do not support multimodality as of now. So now let's just jump to the code. Okay, and we'll see multimodality in action. What we will do, we are using chat OpenAI. Okay, because OpenAI supports multimodality. If you can see here, you'll see that OpenAI, OpenAI is here, and it supports multimodal exchange of the inputs and outputs. So here what we have done, we have used a model of GPT for a audio preview. Okay, so this model of OpenAI has the capability to deal with input data which is of type audio. Okay, so not just text type, it can support, it can work with audio data also. So for this, what I have done, I have downloaded one file of called Harvard.wav. Okay, this is the audio file that I have downloaded. If you see here, if I just play it for you,
the stale smell of old beer lingers. It takes heat to bring out the odor. A cold dip restores health and zest. A salt pickle tastes fine with ham. Tacos al pastor are my favorite. A zestful food is the hot cross bun.
so this is an audio file that I have imported, and most importantly, what I have done, I have converted the audio into a base 64 encoded format. Okay, that's the important thing. See, LLM somehow, in order to make the LLM understand about the audio file, it has to be converted into some format, right? I mean, it cannot just directly process the live audio signal. It has to be converted into, let's say, base 64 in this case. And if you are dealing with images has to be maybe converted into some base 64 format, or images can be utilized we can generate multiple different kind of captions and description for a image. Okay, using some OpenCV model or image processing models, right? And then utilize those description and feed it to the LLM to take further actions and do further furnishing on the input. So this is what we are doing here. In this case, what we are doing is simply converting the WAV file, the audio file, to a base 64 encoded format. Now this base 64 encoded format will be passing to the model. Okay, here I am invoking the model as the audio data for. Okay, if you see, I am passing the base 64 encoded format as the audio data here. Okay, so there are two sections, obviously, two types of message which you are sending. First one is to transcribe the following, which is a text data, the instruction that I am giving. The second one is the input audio, because this is the format which this GPT-4o audio preview model understands. Type is input audio, and input audio in the data I have given the base64 encoded format. Okay, in the original format of the file also we have given. Where now if I print this, okay, it will take some time to process, and let's just play this audio in parallel. Let it generate the response first. It will take some time because it is, yeah, it has generated the output. That means it was correctly able to, you know, um, create a transcription for the given input audio file. Okay, now let's just run this and see.
The stale smell of old beer lingers. It takes heat to bring out the odor. A cold dip restores health and zest. A salt pickle tastes fine with ham. Tacos al pastor are my favorite. A zestful food is the hot cross bun.
So it was successful able to create a transcript for the audio file. So this is just one example of how you can use input data as audio files. Okay, so you can uh, play around with other models and other type of data, other modes of data, PDF, then you have images, right? So you can work with that and it will be fun for you. Okay, so this is how we deal with the multimodal data or multimodality. Okay, so that was about multimodality, nothing else actually. So let's just jump to the next concept. Okay, now we'll discuss about the runnable interface. Okay, so this is a kind of theoretical. See, runnable interfaces are the basic core. It is the foundation block of all different type of components in LangChain. For example, we have chat models, right? Language models. We have output parsers. We can define the parsers. Maybe we'll discuss about parsers when we'll be discussing about chains, right? What is actual chain in the LangChain? I'll create a separate video about that. So output parsers are nothing but the way to format the output. Okay. Then we have retrievers. Retrievers are again related to agents. It is used to retrieve relevant data from a vector database. Again, you can check out my video on LLM agents. You can click on the icon above. You'll get to know about this. Okay. So runnable interface are the foundation block or foundation class of all these type of components. Okay. If you see, um, it can have multiple common methods. Okay, for example, our LLM models have methods like invoke, batch, stream, which you already saw when we were discussing about chat models, right? So these are nothing but these have been inherited from the runnable class. Okay, runnable interface. So there are some other methods which we already saw about streaming and streaming, right? We can stream the output from this runnable configs, okay, or runnable interface. Streaming means as the output is generated, we'll go on we'll go on receiving the output from the LLM model instead of getting the entire response at once. We're going to discuss our stream next, so don't worry. I'll show you a live code example also. So if you see, there are different type of components which are built upon this runnable interface. Okay, the prompts which we design. The prompt is also a runnable config. You can invoke a prompt actually. Then we have a chat model. Is nothing but the chat model class we already saw. Then LLMs. Okay, so LLM models, the actual models that you use. Then output parser, which we'll discuss in a while. I mean, and then we have the retriever. Retriever is used to as I told, to fetch relevant data from vector database. So then the tools. Tool calls which we saw in our previous section, tools are also a part of the runnable interface. Okay, they inherit a few methods and properties from the runnable interface. So tools can also have this kind of invoke, bash, stream, all the kind of methods they can have because it belongs to the runnable interface. Okay, so then that there is runnable config which we already discussed when we were discussing about tools. Okay, so in runnable config is a extra set of um, second argument, okay, that you can pass along with the different methods that it supports. As we saw, runnable interface supports invoke, bash, stream, and stream events methods. So inside these methods is a second argument we can pass this runnable config. Okay, and runnable config can have one or more of these keys: run name, run id, tags, metadata. Okay, if you see here, this is one sample that they have given. Okay, some runnable. Let's say it's a chat model, it's a prompt, or it's a, let's say, what is it? It's a, let's say, tool. Okay, so these are some of the components with a runnable interface implemented. So we can invoke them with some input, that defined input, okay, which they support as the first argument. In the second argument, we can actually pass a config like this, and here we can pass any kind of metadata configuration that we want as we want. Okay, so but the parent keys of this runnable config has to be one or more of this. Okay, So that's how the runnable configs works. Yeah, this is what a chain looks like. Okay, this is just a gist I'm giving you about a chain. If you see, chains are components of a chain are separated by a pipe symbol. Okay, so this is just show the flow of, this shows the flow of execution of input. Okay, input will now first come to the prompt, then prompt output will be passed to chat model. Okay, then chat model's output will be passed to the output person, then the final output will be generated. So it's a complete chain. Okay, chain of sequence of execution of the LangChain. Okay, again, don't worry, I'll create a separate video as I told. So this was about runnables. So next we'll discuss about streaming. Okay, the name suggests itself. Streaming is, streaming the output. I mean, as the output is generated, you send the output in a chunk by chunk manner instead of just waiting for the entire LLM to process your query, then generating a big chunk of data and big chunk of output and throw it on your face. Not like that, because streaming can be, quite useful to enhance the user experience. Okay, so we can actually stream the output in a synchronous manner and asynchronous manner also. For asynchronous streaming, we use stream, where you don't want the output to be generated in a sequential, in a chunk, word by word manner. You want the output to be generated in a parallel manner. You can use stream, but for synchronous streaming, you can use stream. Okay. Now, without just uh, wasting much time, let's just see the code of streaming. Okay. Now I'll show you. Yeah, this is where I've created. See, this is a prompt template that I've created. This is my prompt. Then there is output parser. Then I've created simple chain. Okay, we have a prompt. Okay, this is my prompt. Then we have the model, which we have already, initialized here. Okay, then we have the output parser. Then what I am doing for event in chain.stream. If you see, I am just using a stream. I'm just invoking the, I'm just calling the stream method of this chain, and then passing the topic is Indian cricket. Okay, so that it will uh, invoke the prompt, because the first layer is prompt, right? So prompt will be invoked with this topic Indian cricket, and the final prompt will be tell me a joke about Indian cricket. Now we'll see how the stream works. Okay, if I just run this, you'll see that the outputs are generated. Yeah, now it looked like it generated output at once because it was too fast for our eyes to catch. So what I'll do, I'll just do a timed sleep of 1 second once. Okay, then we'll see. Okay, now if you see, it will just generate the output in a word by word manner. Okay, what did it will generate a stream of response like this. So ChatGPT, that's how it shows you the animated response, right? Word by word it comes up, right? So this is how it is generating the output in a stream manner. So I hope you understood the four concepts which we discussed just now. So we discussed about structured output, multimodality, runnable interface, and streaming. Okay. So if you have any doubts about whatever we discussed in this video, put them in the comment section. Let's discuss and get your doubts cleared. Okay. So that's how you build a chatbot which can, read from external documents. The external documents can be PDF, it can be text, right? It can understand some external documents, and you can then build a Q&A system, question answer system based on those documents. You can upload, let's say, 10 or thousands of research papers or PDFs, right? Or let's say your textbooks. Then you can create a chatbot around it. We are going to discuss four or five, I think, five more concepts of LangChain framework. So in our previous section, we discussed about structured output, multimodality, runnable interface, and streaming. So now we are going to discuss about document loaders, retrieval, text splitters, embedding models, vector stores, and retriever. Okay, so this 5 to 6 components we are going to discuss. Okay, with coding, obviously, so that you'll get to understand about it in detail. Okay, so first we'll discuss about document loaders. So as the name suggests, document loaders is used to load some document, and document can be of anything, right? It can be a PDF, it can be a plain text file, it can be a JSON, it can be HTML, it can be a code file, Python code, anything. It can be anything. So using document loaders, you basically load the documents, okay, into the memory. Then if we see here, there are a lot of different type of techniques available to load different type of documents. Okay, you can load CSV data also, web pages also, right? Then JSON data, lot of data types are available which for you to load. Okay, so in our example, what we have done, let me just import my key first. Okay, then we are importing the text loader. Okay, because we'll be playing with a text file. We have a sample text file. I'll show you this. Okay, we have some information about AI here. Okay, some short history. So because the file is text file, that's why we are importing the text loader package. Okay, so if you want to load any other type of files, there are obviously options to load PDFs also. You can go with PDFs, but for the simplicity and for an easier understanding, I'm going with the text file for now. Okay, so what I've done here, we have just used the text loader to load the document, and if I run this, you get to see that content of this. Okay, the content of this has been uh, converted into a document object. Okay, this is a document class that is available in LangChain, and so it has been converted like this. Okay, so it has added some metadata also. Source is the sample text, the name of the file, and the page content, and the content of the sample.txt file has been added here as a document. Okay, so that was about a document loader. It enables you to load documents from different types of files. So the exciting thing here is when you load from a PDF. Now PDF can contain multiple types of thing, right? It can contain images, it can contain tables also, plain text also. So that's where the PDF rendering and loading PDFs becomes very tricky and very interesting also. If you see here, when you load a PDF, what it will do, it will the package that you will use, right, to load the PDF. Maybe a PyPDF loader package is there. You can use that to load documents in your LLM application. So it is quite smart enough to detect the tables, then sections of the paragraph, right? It is smart enough to detect the section, then convert it to a text data. Okay, like this. Okay, if you see, the table has been converted like this. Table 1, current layout detection model in layout parser. If you see, current layout detection models in layout parser model zoo. Okay, then that the columns are the database model, large model, nodes, etc. So dataset, base model, large model, nodes, etc. So that's how document loaders work. It helps you convert the file data or content of any type of files into documents like this. Okay. Next thing is, the next concept is the text splitter. Okay. Now, why do we need text splitter? See, before understanding why do we need text splitting, first let's just understand what is text splitting. So what text splitting does is it converts the big document. Now, in our case, we have a smaller document here, right? But if the document size is too big, let's say it has pages of content in it. So in that case, it becomes sensible enough to divide the document into smaller chunks, right? We call it as splits. Now the splits can be done in multiple ways based on the length of the number of words, based on the number of characters, based on the number of sentences, based on the type of data. Okay, there are multiple ways to split a big document into a smaller set of chunks or splits. Okay. Now the reason for splitting documents are given here. For example, handling non-uniform document lengths. For example, as I told, in this case, the document length is small. I mean, we have very limited content. But if there will be another document which has a large number of content, a large amount of content in it, then dividing it to splits makes sense, because splitting the document into smaller chunks or smaller manageable chunks makes it easier for storage, right? Finally, when we have different type of documents, we have to store it in a vector database. I'll be discussing about vector database in a while. So it helps storing a big file into smaller chunks in a vector database, so that information retrieval becomes easier. Okay, information retrieval, as in when user asks some question, you might want to search some relevant information from that document, right? So the document can be a book also. You are not going to pass the entire book content as the content to the as the context to the LLM, because that will be very lengthy. So that's why what we want to do, we want to fetch relevant information from the book to answer to the user query, then pass that relevant information along with the query as the context to the LLM, then LLM will be able to answer that question. So that is why we split the documents. Okay. um, so there are some advantages that is given. Overcoming model limitations. um, as you told, many embedding models, language models, have maximum input size constraints, right? So splitting allows us to process documents that would otherwise exceed those limits, right? I mean, when we have big documents, splitting into smaller chunks makes it easier to convert it into embeddings, vector embeddings. I'm going to discuss about it, don't worry. Then store it in the vector database. Okay. So improving representation quality. Okay. Then enhancing the retrieval precision. That this is what I was talking about. Retrieving relevant or related information, relevant information for a given user query becomes easier in this way. Okay. Then there are different type of approaches to split a big document. For example, it is length based, right? Based on the number of characters or words, you can split the document. Then there are other techniques also. You can use a recursive character text splitter method. So this is a quite popularly used way to split a big document. So what it does is, based on a given chunk size, let's say you passed a chunk size is 100. Before that, let me show you how we have split our document. Okay. So what I have done, I'm using a character text splitter. That means based on the number of characters, I'll be splitting this document. Okay. So in each chunk, I mentioned that maximum it can contain 500 characters. Okay. So this text splitter is smart enough to split the document such that it maintains the content. It's not like it will it will cover the first 500 characters. Let's say the first 500 characters ends here in this auto no mo. Okay, it's not like it will split. I mean, it will consider this as the first split. No, because it doesn't have any meaning, right? I mean, this half split word doesn't have any meaning. So while splitting, the text splitter is smart enough to preserve the content, right? It will maintain the length of the paragraph. It will maintain the entire paragraph or the entire sentence. Okay. So that's why this is the maximum chunk size. Let me just run this. It will be very easier for you to understand. If you see now what it has done, it has converted this into how many? One, two, and three chunks. Okay, three document section you can see. Now if you see here, this is the first paragraph that it is converted, right? If I print this, it is only 317 words, right? So even if my chunk size is 500, it still kept only 317 words in the first chunk or the first split. So that's how it maintains the semantics of the each split, right? Now if you see, if someone comes and reads this content in this chunk or in this split, the content itself is self-explanatory, right? It doesn't have any half-baked information or half-cut sentence in it. Okay, that's how the split text splitter works. So here I used a chunk, character-based text splitter. There are other type of text splitter also. For example, recursive character text splitter. What it will do, given a chunk size, okay, it will first preserve the semantic meaning of a long paragraph first. Okay, if the long paragraph itself uh, is more than of chunk size 100, then it will try to split. It will try to create split with this complete sentence first it will try with the complete paragraph. If the character length is beyond 100, it will try to create a complete sentence, create a split with a complete sentence. If the sentence itself is too long, it's more than 100 characters, it will then try to create splits with sub sentences which have some semantic meaning. Okay, that's how this text structure based text splitting works. Then there are document structure based. For example, uh, you can have HTML documents, you can load JSON documents, you can load code files also, right? So while splitting this kind of documents, instead of splitting in a character based, for example, if you split a Python code based on a character, right? Character count, it doesn't make sense. The entire meaning of the code will be lost. So in that case, what it will do, the document structure based text splitter are smart enough to let's say split a code file by functions, classes, or logical blocks like if else conditions. And if for HTML file, it can split it using text. So that's how this document structure based text splitting works. So you can try out different methods based on your use case, but here we have use a characters text splitter. Okay, so now we see we have total 3 split documents. Our big document is split into 3 parts now. Okay, 3 self-explanatory with parts which has its own meaning, own semantic meaning. Okay, now let's jump to the embedding part. So embedding means converting a textual based data or text based data to a number or a vector, right? You can watch my this video where I have discussed about how to convert text into vectors. Different type of methods I have discussed. So why do we do that? Because computers do not understand plain text, right? Everything has to be converted into numbers. So using this embedding model is a it's a trained model with some weights in it, right? Which knows how to convert a text data into a vector or a sequence of numbers, and vector is nothing but a space in n dimension, right? So I'll suggest you to watch this video, okay? Text to converting text into vectors, that will give you a very practical insights of how to do this. Also, I'll suggest you to watch this video where I've discussed how Spotify recommends songs, right, for you using vector search. So that will give you a practical insights about how vector database works, what is embedding, and how similarity search work. How do we find similar songs, right? How Spotify finds similar songs to the song that currently you are listening to. That's how the vector similarity search works, right? So I'll suggest you to watch those two videos first. Then you come back to this video. It will be very beneficial for you because if I discuss those in this video, the video will become lengthy. That's why. So embeddings are nothing but, as I told, it's a model, ML model with some weights, which knows how to convert a text data to a vectors, right? Vector is nothing but or a point in an n-dimensional space, right? So that's what embeddings is all about. In our case, we are using OpenAI embeddings, right? We are using the OpenAI model to create vectors, right? Or create list of numbers for our documents, right? We have 3 documents here. For each of them, we will be creating a vector here, okay? Now, if you see, we are importing the OpenAI embeddings model, okay? This is the embedding models that we are importing. Let's run this. Then we are creating, vectors for our split documents. So if you see the split documents, we are passing along with the embedding model, okay? So in this, these are the split documents, and we have the embedding models, and this will output us the vectors, list of vectors, okay? Let's say this is document 1, this is document 2, and this is document 3. I've taken a 2-dimensional space for simplicity, but in reality, the embeddings model can create vectors in a multi-dimensional space. Okay, so that's how we have created our vectors first. Okay, you use the embedding model. You now understood about what is embedding, and then comes the vector store. See, when we created these vectors, right? When we created these vectors, let's say this sequence of numbers that we got, this has to be stored somewhere, right? That's where the vector stores come in. Okay, so the job of vector store is not only to store the vectors, but it acts as a database to find the similar vectors, right? As you discussed, let's say user has asked some query, and the query has a vector something like this, okay, or something like this. So in order to find the closer documents, right, the similar documents for this user query, we have to search among these 3 other vectors, right? Like which other vectors are closer to this. We can see that this vector is closer to this user query vector. So this kind of search, similarity search algorithms, then indexing the vector documents, then finding a similar other vectors, this kind of things are done by vector store or a vector database. That's why vector store are important. So if you see here, vector stores are frequently used to search over unstructured data such as text, images, and audio. So in our Spotify video, you will be able to understand this in a very detailed manner, okay? And to retrieve relevant information based on semantic similarity rather than exact keywords. So what is semantic similarity? I'll just give you a brief, okay? Similarity matrix means you can find a similar vectors using cosine similarity, the angle between 2 vectors. If the angle is small, then the 2 vectors are similar. The Euclidean distance, obviously distance between 2 points. If 2 points are closer, right, this point and this point are closer, then these 2 vectors are similar. And then we have dot product, right? Dot product means we are calculating the projection of one vector into another. If 2 vectors are parallel, dot product will be 0. The more closer the dot product is closer to 0, then that means the vectors are more similar or more closer, right? So that's what the job of a vector, vector database. So if you see, they have used they vectorized 2 documents, and here in this case that they have given, they have used in-memory vector store. That means they are using the RAM as the vector store. Okay, just for this is just for, let's say, learning or POC purpose, not for production obviously. But in our case, we have used another type of in-memory database, a vector database called Phase. Phase is a in-memory vector store given by Facebook. So that's what we are using here, and we have created our Phase vector store from documents. Okay, from documents. Using the split docs and the embedding model. So Phase used this embedding model to create the vectors for us, okay, for the split docs, and then stored in the vector store. This is our vector store that is created. Then comes the retrievers. So retriever, as I told, retriever is nothing but to retrieve and or search on a vector database. Okay, so uh, it is used to fetch relevant documents based on user queries, right? For example, I created a retriever. What it will do, it will just fetch relevant documents from this vector store. Okay, that's what the job of retriever is to. So retriever does the similarity search calculation, and it can retrieve using cosine similarity. It can do so using Euclidean distance method. It can do the similarity search in a different type of ways. Okay, so in our case we have created the retriever also. Okay, this phase provides retriever for itself. There are other type of vector databases that are not in memory, but production grade vector databases are also there, like ChromaDB, then Pinecone. Those are there, and they come with their own retrievers also. Okay, so you can use them. It's retriever is nothing like throwing a select star from this table query. Okay, it's similar to that. You are just reading something from the vector database. That's what retriever is all about. Now what we have done, we have created, this is where we are invoking the retriever. Okay, so what is the main topic of the document? This is the question that the user is given. Let's say this is the document. Okay, and this is the retriever that I have yeah, that we have initialized it, and I'm invoking that with the user query. So what it will do, I've configured that give me the top one, or let's say top two matching vectors. I mean, here if you see the top two closest vector to this user query, let's say this is the user query. Okay, so the top two closest vector are this and this, right? So this will give me those documents for a given user query. Okay, now if this is the user query, if I invoke this, you'll see that it has fetched two documents. Okay, okay, I have to run this first. It was configured with one, that's why it generated one. Yeah, now it has generated two documents, which is closer to, out of these three documents it has generated, um, it has found two closed documents which can answer this question. Okay, if you see that the future of AI, this document says great. If I change the question, let me just go through the text file once. The history of AI dates back to mid 20th century. Where does the history of AI dates back to? If I ask this, where does the history of AI dates back to? Okay, if I just to make the search more stricter, right, I'll just pass k as 1 so that you can test if it is able to find a relevant document or not. Now if you see from our understanding, if you see, in order to answer this question, this document is perfect, right, because this contains information about the history of the AI, right, the first document. Now if I just run this, let's see if it is able to fetch that document or not. Okay, yeah, if you clearly see, it was able to fetch the relevant document as this. The history of AI dates back to this, right, the first one. And if we try some other, okay, the future of AI holds promise for solving the humanity, some of humanity's more pressing challenges. What does future of AI holds? Let's ask this question. Okay, what does the future of AI is? Now it should give me the third document, right? Because the third document contains some relevant information to answer this question. If I run this, see, it was correctly able to find a relevant document like this, of this, right? The future of AI holds promise for solving some of the humanity's pressing challenges. So that's how we use the retriever to find the most relevant or closest document chunks or splits that can answer, that can be helpful in answering this user query. Okay, so that was about the four or five concepts of today. Okay, now here what we have done, below what I have done, I've created a chain. Okay, I've created a prompt template, if you can see here, and then I've created, we are using that OpenAI model as the LLM, and then we are using the retriever, right? We are using the retriever here. Okay, to to get uh, to get the relevant documents. Okay, then passing it as the context to this prompt. Okay, I mean, these documents that we have got, we are passing this content, this page content as context. Then we are passing the question also, this question also, so that it can answer the user query. Okay, now if I just ask this question here, so this is the chain I have created, and this is the user query, which will be passed to this get answer function, and this get answer function first will retrieve the relevant documents like this, and then invoke the LLM chain. Okay, this is the LLM chain where we are creating the prompt and then asking the LLM to answer the query. So if I run this, object is okay, it was able to give a relevant answer for us, right? If I add something, yeah. So what it did, it used this relevant document, right? Along with it, added its own thought to answer some question, right? If you want, we can add this in your prompt also. It's up to you, like how do you want to customize the final answer, so it will accordingly answer to user questions. So that's how you build a chatbot which can, read from external documents. The external documents can be PDF, it can be text, right? It can understand some external documents, and you can then build a Q&A system, question answer system based on those documents. You can upload, let's say, 10 or thousands of research papers or PDFs, right? Or let's say your textbooks. Then you can create a chatbot around it, which can, whatever question you ask, it will be able to go through those books or go through those text data, and it will be able to answer your question. It becomes kind of a virtual assistant for you, right? Which can help you in your research projects, or help you in your studying, in your studying process, right? So that's how these LLMs and these concepts what we discussed today are powerful, okay, to help you design applications like that. So I hope you understood whatever we discussed today in this video. We discussed a lot of concepts actually. Um, we discussed about document loaders, retrieval, text splitters, embedding models, vector stores, retriever, right? So in next section we'll discuss about RAG and agents, okay. Now, if I ask this question again, who won the ODI World Cup 2023? This model was trained on data available till October 2023. So it doesn't have the idea who won the World Cup on November 19th, which is India, right? Today in this video, I'm going to discuss what a LLM is, and how is it different from RAG or Retrieved Augmented Generation, right? So basically, RAG combines the power of LLMs with a retrieval system, okay? So I'm going to discuss what a LLM is, and LLM is large language models, and how is it different from RAG or Retrieved Augmented Generation, right? So LLM and RAG, LLM and RAG are two popular terms nowadays in the AI world. So at the end of the video, you will not only understand the difference between LLM and RAG, but also see some hands-on examples on these two topics, okay, using LangChain. So let's get started. So I'll try to incorporate and explain my understanding about LLM and RAG in the simplest way possible, okay? And how can we visualize two technologies? And then we'll also see some coding in Python, and then we'll see how both differ from each other, okay? So, okay, let's start with the LLM first. So LLM or large language models, so you can think of this as the AI models, okay, like GPT or Palm or Llama, etc. Right? These are the popular models that are built by big companies. So you can think of LLM as a pre-trained model on a big chunk of data. I mean, you have a huge data set and you have trained a model on it. It has the knowledge about the entire data set that it has been trained on, okay. So in the simplest form, you can think of LLM as a model which predicts the next word, okay, given a input sentence word, right, or input sentence. Let's say you're giving a series of words or a chunk of words as input. Then based on that, it will find out the semantic meaning, and it will again, predict the next best possible word that will complete the entire sentence, so that will continue writing a good sentence, okay. That's how LLM works, but it's not that much simple. It has multiple internal layers, like, attention layer, then transformer layers are there, right, which makes up at the entire architecture of LLM. Maybe we'll require a different video to explain the internal architecture of LLM. Okay, I'll create a separate video for that as well. But for now, on a black box level or overview level, you think of LLM as a AI model or a black box model which knows what will be the best possible next word for a given series of words, or a given series of words which has semantic meaning. It's not like you throw random series of words and it will predict the next word. It's not like that. Just like you write a paragraph or write something, right? Or type a sentence or type a message. Similarly, in that manner only, given a series of words which have some semantic meaning in it, it will predict the next possible best word for it, okay, to continue the chain. So that was about LLM. Okay, now let's just go to our Jupyter notebook and see how LLM works. Okay, so if you see, I'm using a LangChain library. It's a Python LLM framework which is used to develop LLM based applications. There are other frameworks also, QAI, different multiple frameworks are there. LangChain is one of them. So I'm using LangChain for this purpose. Okay. I've also created my OpenAPI API key. You can create that and get your API key from OpenAPI, because you will be using OpenAPI models, okay, to test these things. So I've imported few models, few packages, and here if you see, this is our LLM. Okay, I'm using the OpenAI model for this. As you can see, I'm using the GPT-4o mini, and I've defined a prompt. Okay, because if you see here, for each LLM model, you have to pass some prompt. Based on that, it will give some answer or output. Okay. And the main limitation of LLM is it has limited knowledge. I mean, up to the point that the model was trained on, let's say the model that I'm using is right now is a GPT-4o mini. It has been trained and trained on data available in the internet till 2023 October. Okay. So if I ask any questions about an event which has happened after October 2023, it won't be able to answer, because it doesn't have any knowledge about that. We'll again see that. But as you can see, we are passing this prompt. This prompt that you can see, this is the prompt. This is the model, LLM model. This is the LLM model. Then we have created a chain. Okay. We'll again discuss about chain when I'll be creating a video on LangChains in detail. So what we are doing on this chain, we are asking few questions. Okay. If you see, let me just ask this question. This is the first question that I'm asking. Who won the ODI World Cup 2019? If I run this, 1 second, let me just define this. Yeah. If I run this, you will see that it has answered England won the World Cup in 2019. Now, if I ask the other question, like who won the T20 World Cup 2024, if I ask this question, it won't be able to answer. If you see, it is returning like as of now, the T20 World Cup has not been taken place, so there is no winner, which is not correct, right? It just took place on November last year, October this year, right? Sorry, I think July. My bad. Now, if I ask this question again, who won the ODI World Cup 2023? Again, it will send a response. As of my latest update in October 2023, the ODI World Cup has not been concluded, because the final happened in November 2023. Um, um, and this model was trained on data available till October 2023. So it doesn't have the idea who won the World Cup on November 19, which is India, right? So 2023. So that's what I mean. So I cannot provide the winner. Please check the latest source for the most correct information. So as you can see, LLM has a limitation because it has a limited knowledge. Beyond that, or beyond that timestamp, beyond that point of time, if you ask any question about any event that has happened, it won't be able to answer simply. Now, if we understood how the LLM works, it's just a simple model is there. We are passing some prompt and getting some answer and output, and it has some limited knowledge. That's it. That's about the LLM. Okay. Now, to overcome this limitation of uh, limitation in limited knowledge, we will use RAG. So that's where RAG comes into picture. Now, let me just change the slide. As you can see, the uh, architecture of RAG is quite different from the architecture of LLM. In LLM, we just had the LLM model here, right? Prompt was the input and answer was there was the output there. But in RAG, if you see, along with this LLM layer, we have multiple layers involved in it. Okay. So what does RAG do? Basically, RAG combines the power of LLMs with a retrieval system. Okay, this entire system is a retrieval system. Retrieval means it will retrieve some information. Okay, from somewhere. It can be, we'll see from where it can fetch the information, but it will retrieve some information, latest updated information about some events, then use those information to give the answer of the user. Okay, so if you can see here, we have some domain or domain data or document. I mean. We'll again see an example. Let's just first take an overview of this architecture. Okay, we'll have some documents or the data. Okay, which is periodically updated. I mean, which is the latest data. Then we'll convert those documents to this kind of vectors or embeddings. Okay, using open source embedding model, just like OpenAI embedding model. So if you want to understand more about embeddings, then what is a vector? Okay, how do we convert text into vector or long sentences or documents to vector? Check out this video. Click on the eye icon above. There I have discussed in detail what is a embedding and what is a vector, and how do we use this embedding to create vectors for different chunks or different length of text, right? So you can check out that video and you'll get to understand about it more in detail. Okay, so now using this domain document, see everything is finally text data, right? So using your embedding model, open source embedding model, will convert these documents to vectors. Okay, now these vectors, document vectors, will be stored in a vector database like Phase is there, right, which is created by Facebook, and it's a in-memory vector database kind of thing. So which is frequently used for caching purpose, or POC kind of thing, or just to test the LLM workflow. But in production, you'll use a production grade vector database like Chroma. Chroma is a production grade vector database. There are other databases also like Pinecone. I think there a lot of things are there. Production grade vector database. Okay, so then the information, basically we are encoding this information in vector form. Basically series of numbers. You can think of it as axis, right? I mean, a point in a huge dimension place, right? A vector in a big dimension, n dimension space. So once this document information is encoded in the vector database, we'll use a retriever. Okay. Now along with the prompt, we'll pass the relevant documents. Okay, which will be helpful to answer the given query. Again, I'll show you the code right now. But the job of the retriever is to retrieve some relevant document from the vector database, then combine it with the prompt and then generate the answer. Then now this both things will be passed to the LLM, it will generate the output. Okay. Now let me just go to the other next notebook. As you can see, we are you are importing some modules from LangChain. We are importing the face, which will work like a in-memory vector database for us. So you can again check the same video for details about vector database and how it works. Okay, you'll get a clearer picture. So if you don't know about vector database, I'll suggest you to check that video, then come to this video and watch this from the beginning. Then we are using OpenAI embeddings to create the embeddings for our document. Now, if I show you here, see, let's say this is our domain specific document, or this is our latest information about something. So we have some information like India won to T20 World Cup in 2024 by beating South Africa. The 2023 World Cup was won by Australia by beating India. So this information are documents. So this document list that you see, this is our documents. Okay. Now what we do, we'll use this document and this OpenAI embedding to create vectors, right? So then what we do, we are taking the OpenAI embedding, this embedding model we have taken here. Then we are from these documents, okay, we are creating a vector store or the vector database, okay, using these documents and the embedding. So as we saw, documents and embedding will give us the vector store. Now this is the vector store. Then we have created a retriever there. Okay. So phase library provides all these things. We've created a retriever whose job will be to, give the relevant documents for a given user query, then answer the given user query. Okay. Relevant documents it will fetch. Then based on those relevant documents, it will answer to a particular user query. Now if you see, we have created our retriever QA chain, where we are passing the LLM model, right? This is LLM model we are passing, then the retriever we are passing. Okay, this retriever we are passing, this retriever that we have created above we are passing, and now we'll ask some questions to it. Okay, now if you see here, where will the Champions Trophy happen? If I run this question, yeah, it answers that the 2025 Champions Trophy will be held in Pakistan and Dubai in a hybrid model. Okay. Now, if I ask some other question, who won the 2023 World Cup? Australia won the 2023 ODI World Cup by beating India. See how it understands our language. I mean, I mentioned ODI WC, but it's still the LLM is smart enough, right? This is where the LLM comes into picture. Okay. Now this LLM model is smart enough to understand that by ODI WC I mean ODI World Cup, because if you see here we did not mention anywhere about WC. We mentioned ODI World Cup. Okay. Now the LLM model is smart enough to understand this abbreviation and relate it with the full form of World Cup, right? Now, if I ask the same another question, who won the 2020 World Cup? See how I've written the 2020 here, okay? And again, WC I've written instead of World Cup. If I write this, run this query, it will again be able to answer the question. It will take some time. Let's say, yeah, India won the T20 World Cup by beating South Africa, right? Here I mentioned a T20 World Cup, but here I asked 2020 WC. Okay, that's where the LLM comes into picture. Now let's ask the other question. Who won the 2024-2020 World Cup? There is just a format, I mean different format I've asked the same question. Now, which trophy will happen in a hybrid way? Okay, now you're asking like, see, the T20 World Cup, ODI World Cup, Champions Trophy. Now, which trophy is going to be held in a hybrid model, right? Let's just ask this. And it clears answers that the 2025 Champions Trophy will be held in a hybrid model. Okay, so it fetched the information from this, and then it created its own answer and answered an appropriate response to us, right? Which cup? Now let's answer this. Let's ask this question. Again, it is able to answer the question. So the point of telling you all this about the RAG system is, see, this can be a domain specific document. Here we just took some random example of, about cricketing stuff and all. But let's say if you're building some application for your use case, let's say you have opened an online coaching platform or tutorial platform where you teach online and share study materials, PDFs, and lecture notes with your students, right? And while going through those lectures, videos, study materials, the students might get some doubts, right? And they will again put the question in a Q&A portal. Then you will review the question and answer them. To automate this process, what you can do, you can actually create a LLM application using the RAG technique, where what you will do, you will use your domain specific document. That means your domain specific documents are what? Your video lectures, right? Then your study materials, the notes that you have said, the PDFs that you are using to teach the students, right? All those documents you can convert it to embeddings using open embedding model. So obviously the video can be converted into its script, right? Text script. Then that entire document can be vectorized, yeah, using open embedding models. So it's not like each file will have a single vector. It doesn't work like that. If a document size or the length of the document is too big, it is divided into some chunks. Okay, chunks means some section of the document or section of the paragraph. Then the chunks will be converted in document vectors. So that's a different topic. We'll again discuss. There will be multiple things coming, like how to use text splitter to divide a big document to simple chunks and create multiple vectors out of it for easier retrieval and easier and efficient retrieval by the vector database. So those things we'll again discuss. But yeah, coming back to the topic, for your domain specific documents are video lectures and notes as I discussed. You will vectorize them. We'll create a vector DB out of those information. Then users or students, in your case the students are your users, right? Students will come and ask their doubts. Those doubts will be, and the doubts or the queries will be used by the retriever system to fetch relevant documents from that and combine these two things to generate a proper answer to the questions, right? So this is just one use case where the RAG technique or retrieve augmented generation technique can be used. So there will be multiple other use cases like this. So basically, see, LLM does not know about your online teaching materials, right? LLM is a generic model. Similarly, let's say in a manufacturing company where they have a lot of equipments running, a lot of machines running, a lot of sensors are there, right? Let's say in there they want to have some kind of LLM application to check the status or efficiency of their machines or equipments that are running. So they have to whatever data they have, domain specific data, they have to again vectorize those database. Then they can use the LLM on top of it. So these are some of the use cases. There will be a number of use cases which you can actually use RAG technique to create a LLM application around it. So just to review, LLM is a simple architecture like this. There will be a model, and in RAG we actually retrieve some relevant document. The name itself contains retrieval, right? So we'll retrieve relevant documents. First store relevant documents in a periodic basis. Then when a user query comes, we'll retrieve relevant documents. Okay. from the vector database, combine these two things, and then passing to the LLM to generate the response. So I hope you understood the basic difference between LLM and RAG. So RAG is a superset of LLM. Basically, without LLM, RAG cannot exist. So I hope you understood how RAG tackles the problem of LLM not having knowledge about the events that has happened after it was trained, right? If you ask anything out of that data set or out of that knowledge that it was trained on, it won't be able to answer. But RAG, efficiently and smartly solves this problem. I hope you understood this basic difference. We're going to discuss about LLM agents. Okay, so in previous video we discussed what is a LLM and how is it different from RAG or retrieved augmented generation, right? So in today's video we are going to understand a new topic that is a buzz in the tech market, right? It's about LLM agents. Before understanding about LLM agents, let's just think about what is an agent. Agent is something that can do some work, right? I mean, you give them instruction and it will perform some task by itself, right? So that is an agent. So in LLM agent, we use LLM to do some task for us. Okay, using LLM, obviously in different steps we'll use LLMs. We'll discuss that about in this video. So using LLM, will build agents which will do different kind of tasks for us. Like let's say doing financial analysis on a given set of stocks, right? Every day, like every day it will do some research on the stocks that you have set, right? And it will give you the reports or summaries, right? Or a research paper agent which will read research paper, understand the context and understand everything from it and summarize things for you. So a lot of things can be made using agents. So in technical term, LLM agent is kind of a system or application that uses large language model. Obviously LLM itself is large language model, so it will use LLM or large language models to perform specific tasks by acting almost autonomously or semi-autonomously. You just configure it or program it once and it will do the similar kind of task every day for you. Okay, so if you look at a typical architecture of a LLM agent, so LLM agent mainly contains four components in it. Okay, one is the first component. The first component is to detect the intent of the user query. I mean, this is the input, right, that the user gives. Using this input, we'll first understand what the user is trying to ask, or what is his motto behind the question. We'll detect the intent in the first component, and in the second component, we'll then after understanding the context about it, we'll plan or do the reasoning. Reasoning means we'll decide what are the steps that needs to be done in order to answer that particular query. First we understood the query, then we are designing the steps and plans for the to answer the query. Okay, then once the planning is done and the reasoning is done, we'll use multiple tools. I mean, tools are kind of independent function, you can think. We're going to see code examples of how LLM agent is done and how tools can be used in it. Okay, so tools are different kind of independent functions which perform a specific set of tasks. Okay, so based on the steps that we have got using this planning and reasoning step, we'll then accordingly call the respective tools. Then it will generate response using these tools. Now once the output is generated or the response is generated from each of the steps, okay, then we combine the response and generate the final output which will be given to the user. So this is very generic and simple architecture and heart of LLM agent. I mean, these are the four basic steps that you will find in any kind of LLM agent that you will come across. Okay, so now let's just directly jump into the code. Okay, and we'll see how LLM agent actually looks, right? Before implementing LLM based agent, what we'll do, we'll first design a skeleton and just do a simulator. We'll just design a simulator what to understand these four steps. Okay, we'll understand these four steps or four components of an LLM agent using a simulator code. I mean, we won't use LLMs directly in that, but we'll see how does it look. Okay, now if you see here, we have created a class called LLM agent. This constructor we have for this class. Then we have two methods here. Okay, one is the ask and one is the calculate. I'll explain what are these functions. Now if you see, we have created one function named mock LLM, which is nothing but it first uh, understands the query. I mean, this is the entry point of our LLM agent. I mean, this is the which will detect the intent. Okay, so this is our component to detect the intent of the user question. Now we have created that agent. If you see here, we have created one agent instance using this LLM agent class. Okay, this class we have created. If you see, if I ask something, let's say I ask uh, agent.ask, I just ask hello. So what we have done, we have hard coded here is key if hello is there. I mean, see, as I told, this is just a simulator code. Okay, next we will implement agents using real LLMs, but this is a simulator to just make you brief about. I mean, just give you a flavor of how agent workflow works actually. Okay, now if you see, we have created the agent here and we are asking the first question hello. So the first step is to detect intent, right? What the user is trying to do. So if you see here, so we are calling the ask method of this agent. Now let's go to the ask method. If you see here, what we are doing, if there is something else, I mean something else is mentioned in the query, we'll do some steps. I'll discuss about this condition. Else, what we are doing, we are just passing the query to the model as in this function that we passed here, right? This mock LLM function we passed, and we have passed it as the model, okay, in this LLM agent class. So else it will just return the output from this model. Okay, this is our mock LLM model. Just think of it as a mock LLM model. Now if I ask this question, what it will do, sorry, let me just run this first, and now I'll run this. Yeah, if you see here, it went to this ask method. Calculate was not there, so it went to the else case. So what it is doing, it is asking the model or mock LLM model to generate a response for that. So in this, if we have coded that key, if hello is there, if hello string is there in the user query, you just greet the user like hello there, how can I assist you today? Okay, now if you see here, if I ask this question, now the next question, if you see, I'm asking, can you calculate 12 into 5? Okay, I mean, I want to calculate the value of 12 into 5 here. So if you see here, we have the calculate string here, right? So I have written a rule, hard-coded rule. Again, this is I mean, this input understanding, right? This is where this input understanding comes into picture. Detecting intent. First we first we'll detect the intent. So this is where we are detecting the intent using a hard-coded rule here. Obviously, we'll use LLM in our real agents that we are going to design. But here we are just using a hard-coded rule just to give you the flavor of LLM agent. So the rule is if calculate is there in the query, that means the intent is to calculate something, right? The intent is detected now. Now we move to the next step. How do we now plan the plan to respond to the query? Now the query is, can you calculate 12 into 5? We know that we have detected the intent that it intends to calculate something, some mathematical expression. Now once we have done that, we move on to the planning and reasoning step. If you see here we are doing the planning and reasoning, right? First what we are doing, we are actually fetching the calculation or fetching the mathematical expression from the user query, okay, using some hard-coded rule again here. Then we are using this calculate function. I mean, if you see here, it's nothing but the eval of in mathematical expression which evaluates a mathematical expression in Python. It's just calculating the value and then returning a string key. The result of the expression is this much, right? So if I ask you this question, let's ask this question. Yeah, if you see the expression that it passed, if you see here, I have printed the expression here, okay, from the query. So we have done the planning and reasoning. I mean, we know now what we want to do. So planning and reasoning was done here, okay. Fetch the expression first, okay. That was the planning and reasoning step. Now the next step is to do a tool call. I mean, to calculate the value of mathematical expression, we need some tool. So here the calculate function that is there, right, that acts as a tool call for us, right? So once we got the expression, now we're doing a tool call here. So and then getting the result of the user query. So if you see, it calculated the result of 12 into 5 is 60. Now, if I ask something out of the box, which the LLM agent is not trained or built to answer, right? If I just ask this, it will simply tell that I did not understand the query, okay? Because first of all, the intent was not to calculate anything, right? That's why the intent fell back to this else case, right? And here, if you see, our model doesn't know how to answer this query. Okay, that's why it responded like I did not understand the query. Now, if I just 12 by 5, if I ask this, I think the question mark is there, that's why it is not able to compute. But if I remove the question mark, because we have hard coded the rule to extract expression from that. So if I just do this, yeah, it is giving the value for us, right? If you see here, after the tool call, this is where we are, gathering the result, right? And preparing a response for that. Okay, this is where the tool call happened. This tool call happened. After this tool generated some output, we used that output to generate a final response. So we generated the output for the user query. This is a simulation agent. I mean, I have not used any real LLM here, but now let's move on to the next code that I've created here. And here we'll actually use the real LLM. Okay, I mean, we'll in each step, like the intent detection step, then planning and reasoning step, we'll actually use LLM models. We'll use OpenAI ChatGPT model, right? We'll use OpenAI models to detect the LLM to, let's say, fetch the mathematical expression from any user query. Let's say if the intent is to calculate something. So we'll see the power in a while here. So let me just run this, import some modules here. And if you see here I'm defining few tools. I have one calculator tool which will take in some mathematical expression and evaluate the result for us, right? And then I have a weather tool, which is a kind of simulator tool. It's the description is not correct. Weather tool is gives the weather info of a location. Okay. So here we are. See, in this tool, for now we are just passing. We are sending a hard-coded response here, right? Like 25 degrees Celsius and the weather is sunny. But here we can actually, do some, call. Maybe we can call a weather API here. Okay. We have multiple weather APIs available. You can actually call a weather API, but for simplicity, I have hard-coded the response. Okay, you can obviously use the weather APIs from Google, and a lot of weather APIs are available there. You can obviously write the code for that, and will get the real response for a given location. But here we are, for simplicity, we're just using a hard-coded response. So these two tools we are using. Okay, and then we are using a third tool as a fallback. I mean, if the user's question is beyond or out of the scope of these two tools, right? It will fall back to this fallback tool, and it will generate a response that, sorry, I don't know how to answer that question. So then, yeah, if you see here, we are using LangChain. Okay, so LangChain is nothing but it's a great framework to build LLM agents, right? Agentic based applications. It's a very good framework to use. That's what I'm using here in LangChain. We have other frameworks also, different kind of frameworks you'll find in the market, but here I'm using LangChain. I'll create a separate video on LangChain and how different kind of capabilities that it provides. What is a LangChain? What is a LangGraph? What is a LangSmith? A lot of things. It has built a complete ecosystem actually to generate to build LLM based application. We'll discuss about that in a separate video. Don't worry. So now, if you see here, so we are using the decorator tool, which is provided by LangChain, to mark a given function as a tool. Then we are combining these tools in an array. Okay, this is our tools array. We are creating each tool using this tool class that is available from LangChain. Okay, if you see from LangChain agent, we are importing tool class here. So using this tool class, we are creating 3 tools. Okay, for us. Now, if you see here, for each tool, we are providing some description. Now, this description is very much important. Okay. Now, because the agent that we're going to build using LangChain, that agent detects intent using this description. So this description is very much useful. So if you write something random, it won't be able to understand whether to use a calculator tool or not. Okay, for a given mathematical expression. Okay, so this description is very much important for the LLM agent, LangChain agent, to understand what a function does actually. Okay, I mean, which function shall I call for a given query. Now, if you see here in the weather tool, we are again giving some description like useful for fetching temperature of a location that the user has asked for. And this fallback tool is for if no other tool is suitable for the user query, use this tool. Okay. So for each tool, I have given some description which will be helpful for the LLM agent that we're going to build. Now, if you see here, I have created the one LLM model using, as I told, we are using OpenAI model, right? So I'll just run, and then we are creating the LLM agent using the LangChain. This initialize agent is a function from LangChain, okay, to create an agent. Okay, if you see, we're passing the tools, we're passing the LLM model. Okay, and then was false I have given here. Okay, uh, again I'll make it true and I'll show you how it works actually. Let's just run this. Let's just initialize our agent first. So our agent is initialized. Now we are asking few complex questions. See, the questions that I'm asking here, it is not pretty much straightforward. See, if you see here, I've asked, hello, can you tell me what 5 multiplied by 6 is? I'm not given any mathematical pure handwritten expression like 5 into 6. I've written in like 5 multiplied by 6. So if you see, this LLM agent is smart enough to, you know, uh, get the mathematical expression for it. Okay. Then utilize it to utilize the calculator tool to calculate the expression. So internally it is doing a lot of things. Basically it is abstracting a lot of things. Okay, I mean, LLM agent, if you use some framework, that's the benefit of frameworks, using frameworks like LangChain. It will abstract a lot of information for us. In the next Python code, I'll show you how to implement this abstraction. I mean, how actually we can answer this kind of complex queries, okay, by detecting intent using LLM model ourselves. We'll again see that in the third file. But if you see here, if I ask this question, see that, let it just generate some response for us. Yeah, if you see it is correctly answered, the answer is 30. If I ask this question, what is the result of 25 divided by C? It is again correctly answering the question. But if I ask something out of the box, because the LLM agent that we built, it purposes to perform two tasks for us, right? One is the calculator tool and one is the weather tool. So our LLM agent only knows how to compute some mathematical expression, how to uh, give the weather of a particular location. If I ask this question like this, you'll see that it will go to the fallback tool, because it is neither useful for the calculator tool, nor it can be answered by the weather tool. So it is fallback to the for our fallback tool, the third tool, and it is generating response rate. I'm unable to face the live cricket score of India versus Australia. Please try using a sports news. Okay, generate a response like that. But if I ask this question, it will clearly answer the questions pretty much in a very good manner. And the current temperature BVSR is 25 degrees centigrade, it is saying. Now if I just let me just make this was true, so that we'll understand the different internal steps, right? How it was able to decide that I need to call calculator tool for this, I need to call weather tool for this. We'll see how it was able to do those things. If I keep was true, it will give us a detailed, you know, internal steps that it is performing in order to reach to the particular solution. If you see here, see, entering a new agent executed chain. Now it is internally doing some using LLMs to uh, get the to detect the intent and do the planning and reasoning step, then determining which tool to use in the planning step, then calling the tools, right? All these three steps are being done internally using the LangChain framework. Okay, the LangChain agent is completely abstracting these four steps here. Okay, now here in the verb step we see those steps in detail. If you see here, first it is detecting the intent ki, yeah, I should use the calculator tool to perform the calculation, because the question is kind of a calculation wala question. So it detected action as the calculator, and input as 5 into 6, because it fetched the information from this. It used LLM again to convert this query to a mathematical expression. So it created a mathematical expression for us. Now it is then calculating the calculator tool to give the final answer for us. Now if I run this query, if you will see that it is entering an agent executor tool, it understood that, yeah, so the user is asking about the temperature of Bhubaneswar, so it directly knows that, yeah, I should use the weather tool directly. Okay, so it used the weather tool and gave us the answer of that the current temperature in BVSR is 25 degrees Celsius. So this is how you can design LLM agents using LangChain framework. But we saw that it is abstracting a lot of steps. I mean, this intermediate step that it is performing, it is abstracting a lot of steps here. So now what we are going to do, we are going to implement a real LLM based agent from scratch. Okay, let me go to the third file, and here we will actually build an agent which will again perform these two type of tasks. It will either calculate the mathematical expression, or give the weather information, or if it is not able to find any of these two, it will just simply say that I don't know the answer. So but we will implement each of these steps, right? Because LangChain abstracted all of these steps, right? But we'll, in our scratch implementation, we'll implement each of these steps, okay, using LLMs, and then we'll see how it works. Okay, now let me just, if you see here in the LLM agent class, there is an initializer. Obviously there are, I'm just initializing 2-3 things here, API keys and all. Then the query LLM function is there. Yeah, we have a query LLM function here. The query LLM function is nothing but we will be passing a prompt to it. Okay, if you see that the input is a prompt. Okay, based on the prompt, it will just run the prompt on a OpenAI model. It will just send a response for us. Okay. Now the entry point of this entire LLM agent that we have designed is the detect intent, because this is the first step. Detect intent, right? How do we detect intent? See, if you see, we have generated a prompt here. Okay. Now user is typing something. This is the query. I mean, whatever is user is typing, based on that query, what we are giving in the prompt key determine the user's intent based on the query. The intents can be calculator, whether or other, right? Then we are passing the user query here, and respond with only one word. So this is what the prompt we have designed, and then we are passing this prompt to self query LLM function. Basically, it's just passing this prompt to our OpenAI model. Okay, so this OpenAI model, the LLM here, will help us to detect the intent here. If you see here in the detect intent, we are using the LLM here. Okay, OpenAI LLM. Now once the LLM detects the intent, now what it will do, will process the query. Okay, so if you see here, first we detected the intent using the detect intent function. Once the intent was detected, it can be calculated whether or other, right? Any of these three things. So once this is done, we are doing the planning and reasoning step. And if you see here also we are using LLM. How? Now in the planning, in the, let's say in the calculator tool, user can type something like this, just like we saw here, right? 5 multiplied by 6, but we need to convert it to a mathematical expression. How we'll do that? Again, we'll take help of LLMs here. Okay. Now if you see here, what we've done, we are calling one function, self parse to expression. Okay. If you go to this function, parse to expression, again, if you see, we are using a prompt. Yeah, right. Convert the following query into a valid Python mathematical expression. Whatever is the user is giving in the query, I just um, converting into the expression and responding with the expression. Then again, we are calling the query LLM function. Okay. So it will give us the mathematical expressions. Now once this was done, we know the planning and reasoning has been done. Now let's just do the tool call. Okay. Tool call will do. Now what tool will call? We'll call the calculator tool, because the intent is to calculate something, right? You're passing the expression to the calculator tool, which is nothing but a simple eval expression, right? Eval function we are calling to evaluate the expression. Similarly, in the weather case also, we need to get the location from the user query, right? Again, once the intent was detected, we need to get the location from the user query. So again, in this get location function, we are again using uh, LLM here, right? Because this is the planning and reasoning step. In this, what we are doing, fetch location name for which the user asks for the temperature, respond with only the location name. Again, we are calling the query LLM function to get the location name. Now it will get us the location. Then we are calling the weather tool again, right? Just like we had weather tool earlier. So in weather tool, what it does, it's a mock implementation of a weather API. You can obviously integrate a weather API here, but we are just sending a hard-coded response for simplicity. The current weather in the asked location is 25 degrees centigrade. If it doesn't find anything, it will just say that sorry, I cannot handle this query. Now let's see it in real action. Okay, let me just see what is 5 multiplied by 6 again, or 5 multiplied by 8. Let me just ask this. So if you see here, what it will do, it will processing the query. See, it first detected the intent is calculator. Then using LLM again, it was able to create a mathematical expression for it, 5 into 8. Then it calculated the result. Okay. So if you see here, whatever LangChain had abstracted from us, we are now implementing it from scratch. We are understanding how things are done internally. So if you see here, we are using LLM in two places, here and here. Okay. And obviously in the final output generation, we'll see. Now, the result is 40 here. Now, if I ask this question, see how complex I have given it, right? Can you calculate 25 divided by 5 plus 5? Let me just make it more complex like this. Let's see how does it see. See, it was able to properly get a mathematical expression for this. 25 divided by 5 plus 5. The answer is 2.5. Now, if I ask this question, what is the temperature of Brisbane, Australia? It understood that the intent is to do a weather calculation, and what is the temperature of Brisbane, Australia is the query. So the current temperature of Brisbane, Australia is 25 degrees centigrade, right? Now if I just ask something out of the box, I mean which it doesn't know, what is the current score of India versus Australia for test? Let me just ask this. Okay, now ask this. Let's see what does it give. It understood that it neither falls in the um, weather intent nor in the calculator intent. So it understood that and answered that sorry, I cannot handle this query. So we saw how to implement a LLM agent from scratch, and obviously you don't want to implement things like from scratch like this, right? That's why we'll be using LLM agents. Definitely, if you want to have more control on your input, more control on your decision making using the prompts and all, you may choose this path. It will definitely generate better response for you. Okay, so I hope you understood the details about LLM agent. We saw how we simulated an agent, right? Then we actually implemented LLM agents using a LangChain framework. Okay, and then we actually implemented the entire the entire LLM agent flow from scratch. I mean, because LangChain was abstracting a lot of steps, so we implemented it from scratch. I hope you understood about LLM agents in detail. In our previous video, we discussed about LLM agent, right? I mean, what LLM agent is, what are the different components involved in it, like detecting intent, planning, reasoning, then tool calls, then output generation. So today we are going to discuss about multi-agentic approach, right? How multi-agent system can work. That means if you see this entire thing that we have drawn here, right? Let me just yeah. If you see this entire box, this entire entity that you see, right, the all these four steps that is involved, this is a single agent, right? Now what we are trying to do here, we are trying to combine these multiple things, right? If I group this and just we are trying to combine multiple of this, okay, to generate more powerful output, okay, and more accurate output. Okay, so this is what multi-agent architectures look like, basically harnessing the power of multiple agents. Now in this video, basically what we are going to do, we are going to discuss different type of architectures that are available. As you saw in a previous video, we designed LLM agents using LangChain, then we designed LLM agent from scratch, right? Now we'll see different type of multi-agent architectures that are available, okay, and which the coding community is using. So I'm here in the LangChain documentation page. So if you see here it is defining agent as an system that uses LLM to decide the control flow of an application. So as you develop the system, they might grow more complex over time, so making it harder to manage and scale. So the reason for designing multi-agent system is to, because if you want to have a single agent to solve all of your problems, it will be very complex to design. So what we want to do, we want to break down the functionality of your application into multiple sub actions or subtasks or sub agents, then assign that to individual agents, then let them run and let them process parallelly and independently. Then we'll combine the output of all these agents to generate the final output for a given user query. Because a user query can be complex, right? It is not very much, it cannot be always simple, right? Calculate this for me, or what is the weather of this. It can involve complex calculations where in one step you might need to browse the web, in the another step you might need to process images or process PDFs, right? Or process videos, maybe online videos. So there can be multiple steps to answer complex query. So in order to solve complex queries, to handle complex queries given by the user, we want a multi-agent system. Okay, so we know what is a single agent. So now we want to have a multi-agent system like this. So it is defining three problems. I mean, having a single agent system can have some problems, like agent has too many tools at its disposal, which can make poorer decision. If you want to have a single agent to solve all of your problems, the decision making can be poorer, right? So instead of, we can group them into a relevant set of subtasks and then have different separate agents for that. So context grows too complex for a single agent to keep track of. Obviously, single agent will be feeding in a lot of context, right? Like this, if you see, for each for this intent detection, we are having an LLM, and this intent detection step itself will become complex if we have a lot of things to solve. So the benefit of, so to solve all these problems, we want to have a multi-agent system. Multi-agent system has this benefit, obviously, modularity, because a agent will be focusing on a different subset of tasks, and it will be specialized to do such kind of task, which the other agent won't be able to. Let's say one agent is specialized in generating finance, analyzing financial stocks and financial news, and generating output. One agent might be efficient in analyzing the law documents and laws and law books and law documents to generate insights about queries about laws and all, right. One might be efficient. One agent might be efficient in analyzing multiple research paper on a given topic and generate insights for a given user query. So this is what specialization means, and obviously we have more control over the quality of the output because we are following a modular approach here. Now let's see what are the different kind of multi-agent architecture that people are using here. Okay, so the first is the single agent, which we already saw in a previous video. You have a bunch of tools available at your disposal like this. Okay, and do the tool call, generate the output. One is the network architecture, like we have agents which will communicate with each other. Okay, let's say we have this kind of agents here. So each of this green box that you see here, right, so these are the green boxes here. Okay, so in the network architecture, if each of the agent is communicating with each other, it will exchange outputs and generate the final outputs accordingly. So it is a quite complex architecture. And if you see, the third architecture is supervisor architecture. There will be one node which will be the master node. Basically, it knows the entire thing. I mean, it first understands what needs to be done. It breaks down a complex task into multiple subtasks. Then it assigns the subtask to individual agents. Okay, then it will collect the information and output from each of these agents, collect the output from this agent, then generate a final response for the given user query. So mostly you'll find a supervisor architecture being used for for solving most of the complex problems. Now, if you see here, so the supervisor as tool application is being used here. Instead of having an agent oh, agent as a supervisor, what we are doing, we are having a LLM as the supervisor, and we have a bunch of agents as the tools which will be using to generate the output for a given query. Now there are two other types of architecture also, hierarchical and custom. In hierarchical, it is a quite complex architecture, and the custom architecture where you define your own control flow based on the requirement of your application. So you see here, I mean, whatever we discuss about architecture, it is being mentioned here also. So in supervisor architecture, each agent communicates with a single supervisor. We have a single master there. So supervisor agent makes decision on which agent should be called next and generate the output accordingly. Again, in the third architecture, supervisor tool calling. This is a special case of supervisor architecture. So where individual agents will be used as a tools. Instead of having a single function, we'll have individual agents as the tools. Then we'll have kind of LLM to supervise the control flow to solve a given problem. Then use those agents as tool to answer the given user queries. Okay. Now, as you saw here, hierarchical architecture is quite complex and it is actually quite capable of solving more complex tasks. Okay, so generally we'll be seeing people using this supervisor architecture and hierarchical architecture. For simple applications, people use single agent flow. Okay, so you can go through this documentation. I'll put the documentation link in the description. It is given code samples also how to design a multi-agent architecture. So the core is to understand how to implement a single agent first, okay, from scratch. Once you understand this step, it will be very much helpful for you to design any kind of multi-agent architecture to solve a given problem. So yeah, that was about the multi-agent architectures and different type of architectures available for multi-agent, for designing multi-agent systems. Here actually I have designed a text to Mongo conversion tool where user can just type in their simple questions in their plain English form and it will generate a corresponding Mongo query for us which we can then run on a MongoDB. In our previous section of the video, we discussed about RAG, Retrieved Augmented Generation. Then we also talked about agents and we built one agent from scratch using LangChain. And in today's video, I'm going to explain you about few more basic concepts about prompt templates, output parsers, few short prompting, and example selectors, along with code examples. Okay. So first, let's just jump to the first topic: output parsers. So output parsers we already discussed about which structured output method that is available with LangChain runnables, right? So you can use that to actually structure the output. So this is kind of outdated document. So when those kind of things were not available in LangChain, and also proper tool calling support was not there, this output parsers was being used, okay, to generate output in a desired format. So I'll suggest you to use that only with structured output, then use tool calls to define your output formats and all. But as a legacy, let's just discuss like how output parsers used to work. So if you see, we have different type of output parsers, okay. For example, string output parser, which parses text message from the objects. I mean, the output that is generated will parse the text information from there. You can then extract information in a JSON format using the JSON output parsers here, right? So there are other output parsers also, XML, CSV. So we are not going to waste much of our time in on this. But one important output parser that was there was the retrieval with error. Okay, that means if your output parser somehow fails to generate the output in a desired format, what it will do? It will again pass the current output, the error message that it got, and it will pass it to a LLM layer inherently. It will then fix the output format and generate a proper output for you. So that's how this retry with error output parser used to work. Okay, so you can, if you want, you can try out these things, okay, one by one. So now let me just move to the next section called prompt templates. So prompt templates are, kind of a way to structure the user inputs and the system inputs and the AI outputs also, right? I mean, we had three types of users, right? System, user, and AI, which we saw in our earlier section of the videos. So prompt template is a way to, structure the input format. There are few types of prompt templates that are there. One is the string prompt template. I'll show you example of prompt templates in my code here. Okay, here we have used three concepts actually. I'll show you all of them, okay, together once I discuss all these concepts. So you have string prompt templates where you can, just create a prompt template like this, okay, and you can have a placeholder for variable, okay. Then you can actually invoke your prompt template with this. So what will happen? This topic variable will be replaced with this text. So it's kind of a placeholder you are using, okay. Next we have chat prompt templates. So this is nothing but just like we had a string prompt template, which uh, had only one string, okay. In chat prompt template we can have a sequence of messages in a list format, okay. If you see, it's a list of messages, and the list messages can be a system message, user message, or AI message. Here also you can use placeholder variables or input variable placeholder like this, and similarly you can invoke those and it will give you a chat prompt template. And I mean, in a chat format it will give you the prompt templates, okay. If you think clearly, right, what we can do, we could have write this as a right system prompt and user prompt, then we could have combined that together. So we could have done all those things, that's not an issue. But as I told, this kind of classes helps us to write clean code, obviously, and a structured code which will look, which will be better to understand, easier to understand, and easier to manage and handle also. So next type of prompt template we have is your message placeholder, okay. Here what you can do actually, uh, instead of we deciding the sequence of messages here, okay, what you can do, you can have a placeholder like this using this message placeholder construct, where you can actually pass a list of messages dynamically while invoking the prompt. You can actually create the list dynamically and pass it here, okay. So it's kind of, chat prompt template kinds of become a static implementation. Chat prompt template with message placeholder becomes a dynamic implementation for us, where you want to add the user inputs in between the implementation of the states in a dynamic way, okay. So that was about prompt templates. Anyways, we are going to see the practical code example, so I'll leave you here with this prompt templates. Now let's just go to the few short prompting. What few short prompting means? When you are creating prompts, usually what happens, when we create prompts, instead of having a hard-coded static prompt every time to generate an answer, what we can do in that prompt, we can actually embed some sample examples which match to the user query, okay. So this kind of few short prompting is useful when you are doing a kind of text to some other query conversion mostly, right? Let's say you are converting user query to Mongo query, user query to SQL, text to SQL, text to Mongo query conversion. In those kind of conversion, it's quite helpful to have few short prompting. And in few short prompting, what we will do, we'll basically fetch some sample user input and the corresponding sample output that we are expecting, then pass some of those set, let's say 2 3 such set will pass in the prompt based on the user query. Then we'll generate the output for the given user query. So in this video, in a while, I'm going to show you how to convert user language, user query to Mongo queries. Okay, so we'll be implementing a text to Mongo agent from scratch. Okay, so there we'll be using few sort prompting, and you'll be able to understand that better. Okay, so when generating few sort prompting, as you told, few sort, that means some sample examples. Few sort means some samples. Okay, relevant samples examples which you want to pass along with the main prompt or the core prompt. So there are some uh, points to consider when you are doing few sort prompting, like how are the examples generated, how are we going to generate the input and output pair, like the desired expected input and the desired output pair. Okay, and how many examples are to be there in the prompt when you are creating a dynamic prompt, how many relevant examples we want to pass, whether we want to pass 1 2 3, this question we have to answer. So these are the 4 questions. If I discuss about this one by one, how our examples are generated. So to generate examples, first what you can do, you can have some sample set of examples like this. If you see here, I've taken some synthetic data. Okay, some samples from I've taken some sample examples on my own, where I have some user text and a corresponding Mongo query. Okay, that's the step one, to create some sample examples. Okay, you don't want the data set to be this much only, right? You want it to grow dynamically with some good examples, because this much information is not enough to build a foolproof agent. So in that case, what you can do, you can use user feedback. Let's say user asks some question ki, how many orders were placed in my company this month, and the platform, let's say, generated a corresponding Mongo query for the user. And we can ask the user to give a feedback whether the query is correct or not. If he gives a positive feedback, what we can do, you can then insert this user query and the generated Mongo query into our main database, right? So that's how we generate examples as synthetic data, and we create a good set of example data which can be used for new users also. All right, so this was some of the ways to generate examples. Then the next question is, how many examples are in each prompt? How many examples you want to put? So that depends on your use case. You can have two examples, or minimum one example, so you can go up to 5. The point is, the more number of examples you have in the prompt, the better will be the output. But there will be trade-offs also, because as you include more number of examples in the prompt length will become lengthy, right? It will become huge, which can exceed the context length, maximum context length supported by any LLM model. So you have to then or design some appropriate way to fetch relevant and more similar examples to be used in the prompt, and then select two or top three matching examples. Then you can use those in the prompt. So there are obviously some trade-offs about the number of examples, because larger prompts increase the cost and latency. Obviously, the bigger the context size will be, or the bigger the prompt will be, the higher the cost will be. Okay, for your LLM calls. So uh, so the next question is, how do you select examples? Okay, so there are some ways, like if you have some set of examples like this, you can pick some random 2 3 examples, but that is not the best way to do. Next thing what you can do, you can have some semantic or keyword based similarity of the inputs, right? You can use implement you can implement phase or some vector database. Okay, and then apply semantic search on top of your this synthetic data set, which will find you the top 3 or top 5 based on the configuration matching queries for the given user query, and you can use those in your prompt. So this is the most desired and most efficient and workable way to select examples from a data set. Okay, so LangChain has an example selector, okay, which will fetch relevant examples from a given set of sample data set. We are using example selectors here. I am going to show you here definitely. I think that was about few sort prompting. So now let's just jump to the next thing about the example selectors. So as I told, example selectors, uh, it will be better to show you in the code. Example selectors is nothing but it's it is able to select top 3 or top 5 relevant examples from the given data set based on the incoming user query. Okay, it will apply semantic similarity search, and it will then do so. Then let's discuss about this concept of async programming. So async programming, as the name suggests, it is used to call the methods of our runnables in a async manner. Like we have seen, we can do prompt.invoke or LLM model.invoke. We can do those stuffs, right? What we can do, we can make those calls async, that so that the processing of various activities will be done in an asynchronous manner, which will definitely reduce latency in your application and improve your overall performance of the application. Because in many times when designing LLM based applications, you'll often be integrating some IO operations which will be making external API calls, doing database queries, will be reading from files. Those are, async operations, and in many situations you won't want to do those in a sequential manner. So in those cases you can go for this asynchronous APIs. So almost all the runnable interfaces that are available in LangChain, they support async operations, just like we saw invoke. You can do AI invoke, right? And just like adding, let's say vector, you are adding vector documents in your application. Let's say you have vector store where you are adding relevant examples in the dataset. Okay, so you can make that, asynchronous even. Instead of doing add documents, okay, you can do add documents. A for asynchronous add documents you can do, which will perform the task in an asynchronous manner. So that was about today's concepts about output parser, prompt templates, and few short examples. Now let's just see a example where we'll be discussing about these three things. Here actually I have designed a text to SQL text to Mongo conversion tool where user can just type in their simple questions in their plain English form, and it will generate a corresponding Mongo query for us, which we can then run on a MongoDB, okay, and get the corresponding results. So here I'm just imported some keys. Let me just import my keys. Then we are using the OpenAI embeddings, which we already discussed. This will be used to vectorize these documents. Okay. Then we are using OpenAI as the chat models. Then I have imported some other modules also. For example, chat prompt template, which is just so. I've used the chat prompt template module. We are using Face for vectorization of this sample documents. Okay. Then I'm using the semantic search, semantic similarity example selector. So which will find us the relevant close matching examples for a given user query. Okay. Now let's just import these packages once, and let me just initialize this variable also. And here I have used that OpenAI embeddings, and then I have created a simple plain system prompt. Okay, this is not user prompt or AI prompt. This is a system prompt. Okay, here we are just feeding in the user query. Whatever the user will be passing, we are just using the variable for that. Then this is where we are using all the concepts which we discussed so far. Okay, I have defined a function called load query chain where we are initializing our LLM model and our embeddings. Then I'm using the semantic similarity example selector. Now what this will do, it will first create a, it's just like a retriever, which is saw in our previous section about retrievers and vector store, right? So what it will do, it will use that synthetic data which I've already declared above, then use the embeddings, so that using these embeddings it will convert the synthetic data into vectors. Okay, and then store it in a phase. Phase means, which you already saw, it's a in-memory vector store, in-memory vector store that is available for us, and it is given by Facebook. Then we are passing k is 3. Okay, so example selector is nothing but it's kind of a, creating a vector store plus retriever. It's a combination of both. Vector store plus retriever is kind of an example selector. Okay, then we are passing the user query. Okay, so given the user query, it will go to its vector store and find top 3 matching examples for us. Okay. Then we are creating the few short message prompt, right, where the first parameter we are passing is example selector, because it's a few short prompt template, right? That means we have to have some similar examples, right? So that's why we're using this example selector, which will do that task for us. Then we're creating a chat prompt, okay, which is saw in our prompt templates. Here we are creating chat prompt template, right? So this is what we are doing in our chat prompt template. What we are doing, given the user query, given this output of this example selector, it will create a list of messages like this for user query and Mongo query. Okay, what is the user query and what is the Mongo query based on the user query, input user query. Okay, you could obviously write your own custom prompt template like this. Okay, what you could have done, you could have used a plain rag here. Okay, to fetch top 3, let's say, matching documents from the vector store. Then you could have created your own prompts. That is up to you, absolutely fine. You can do that, not an issue. But this is just a structured way of doing things, and which is given by LangChain. So we should definitely leverage these components and use it to make our code more cleaner and structured, so that I don't have to write much of things from my end on my own. Okay, this is where we created the future template. Then we have the final prompt. Okay, where I'm passing the system prompt first, right? This is the system prompt. That's the first instruction that I'm giving to the LLM. Then we have some few short prompt. That means we have some sample examples here. This is where we'll be having our uh, top three examples, matching examples. Why top three? Because k is equal to 3 I've mentioned here. All right. Then we have the given user query. Now I've created a chain here where we have the prompt and LLM. Then we are creating the query chain here. So this was a function which returns the query chain, and this is where I have created the query chain here. So let me just run this, and then we'll invoke the query chain with our first question. So retrieve first 30 users of Australia, let's say. So it correctly generated the query for me. dv.users.find country is equal to Australia, limit is equal to 30. Let's just ask another question. How many orders were placed in December 2024? Yeah, order that count documents, order that and all. Then let's ask the third question. List all products with price above 200 rupees. So dv.products.find price is greater than 200. You might ask one question ki, what if the column names or the property name in my collection is not order date in this case? What if it is that order placed at? The column names can change, right? As well as the collection name, right? So in order to handle this, also what you can do, you can always in the system prompt you can input some schema information like this. You can craft your prompt like anything you want. Okay, order properties of collection are, you can mention order ID. Okay, order placed it. So if you feed in this information about the schema of your database structure, then your LLM will be more aware about the exact key names, and it can then utilize those to generate correct things for you. Okay, based on the exact collection name and properties name available in your database. Similarly, in your examples also, you can utilize your key names, right, or names of your collection name and properties. So that will help the LLM to generate accurate queries. Okay. I hope you understood today's concepts about prompting techniques, how to create prompt templates, then how to do few short prompting and leverage example selectors to build a tool like this text to Mongo conversion. So we are going to discuss about the last four concepts of our LangChain crash course. So those concepts are callbacks, tracing, evaluation, and testing. Okay, so these four concepts all together are quite useful when you want to debug your LLM application. Okay, so it's not just enough to build your LLM application and just let it run, right? You'll be find yourself in situations where you want to debug your LLM application and you want to get hold of the intermediary steps that it executes in order to give a corresponding output for a given input, right? So that's where these concepts come into picture. So the first concept is the callbacks. Okay, as the name suggests, LangChain supports some inbuilt callbacks. Okay, inbuilt callback methods, which are listed here. As you can see, there are methods like on chat model start, on LLM start, on LLM end, right? On chain start when you start a chain. So these are the different type of callbacks which are supported by LangChain, which you can actually implement in your code. And you can get hold of the intermediary steps. Now if I just show you one code example, let's go here. Let's go here. If you see here, you can define a class like this, okay, logging handler, and then you can define the methods, okay, on chat model, on model start, on LLM end, on chain start, on chain end. So these are the methods that are defined here in this list. Okay, you have to basically define this in callback functions, and you can actually print the corresponding logs and in intermediary values if you want to get hold of, right? Like what is the current messages that is coming, right? What is the state of the current messages list? What are the other arguments? You can print this in your application when you are running it. Okay, so if you see here, they have defined a class called logging handler. Then they have the callbacks, right? They have passed this class as a list here in this callback handler. You can define multiple classes of this. Then they are just, while invoking the chain, here they have defined the chain. While invoking the chain along with the input, you can pass the callbacks as the config here. Okay, so this is how you can actually use the callback feature of LangChain to capture the intermediate states. And if you see here, it is it is displayed a sample output here, right? Chain runnable sequence lasted started, chain chart prompt template started, like based on each step. Okay, the things will be correspondingly called by LangChain internally, and you will be able to see the intermediary states. Okay, so that was about callbacks. Now let's go to the tracing. So what tracing means is, in order to understand tracing, let me go to this slide. Okay, so if you see here, the entire LangChain application that is there, right? It can be divided into three elementary parts. Okay, one is the project, then the traces, then traces as runs. So these are the three elementary units which you can think that a LangChain application can contain. Okay. So when you have a LangChain based application design, so it will have collection of traces, and each collection is a collection of runs. Now what is meant by runs and what is meant by traces? Now a single run, okay, run is a single unit of operation that a LLM agent can perform, or a LLM application can perform. And a single unit of work can be a call to a single LLM or a single chain. It can be a prompt formatting, like you have a prompt.invoke we do, that can also be considered as a run, right? When you do runnable lambda invocation, when you invoke runnables in LangChain, so those are actually known as runs, okay, which does nothing but a unit of work. Then traces are nothing but a collection of runs. So run is the first first elementary unit in LangChain terminology. Then a trace is a collection of related runs that performs a single operation. That means, let's say we have defined a chain. Okay, we have defined a chain which can make a call to the LLM, then generate the response and parse it to a output parser. Okay, and then finally it can, if required, it can call a external tool also. It can do RAG also. All those things are actually individual runs, and collection of those things as a whole is known as trace. Okay, so that is about traces. So using Langsmith, actually you can see what are the traces that are there, right, for a given application. For example, in they have defined it /chat LLM application, let's say they have defined, and in that there are two main trace. One is the retriever and one is the chat OpenAI model, right? So you can actually see the different type of traces and runs in the Langsmith, using Langsmith. So maybe we'll see about this in another video, the practical application of these things. But for now, let's understand the theory only. Okay. And as you told, a project is a collection of traces. So project is nothing but a collection of traces, and traces that are related to a single type of application, or which performs a single type of operation or activity for us. All right. So that was about traces in LangChain. And then comes the crucial part of evaluation. See, it's not just enough for a LangChain application to generate a input given generate an output given an input query, right? We have to evaluate whether the output that has been generated by the LangChain agent is, I mean, valid or not. It cannot just throw out some random output, right? So in order to evaluate our LangChain application, there is a concept of evaluator, okay, or evaluation. The practical application of this evaluation, I have to create a separate video, because that will take entire video, and there I'll show you the code examples, okay, and we'll see a evaluator engine there, and we'll create some components, evaluator components, which will evaluate the output quality of our LLMs. Okay, but for now, first just let's understand what do we mean by evaluator. Now, what does evaluator does? Evaluator will first have some, let's say, samples to reference rate as the reference data. That means it will have some. Let me just open this slide. Evaluator will have some sample data set, okay, some reference data set that it can refer to, and the sample reference data set will have some sample input and the corresponding desired output. That means you are just stating the LLM that if input is this type, I am expecting a output of this kind. Okay, so based on that, we can then use the evaluators. So what are evaluators? Evaluators are nothing but some functions. Okay, you can have your own custom evaluator, or you can use the inbuilt evaluators that are given by LangChain. So you can do both. So those evaluators are the actual functions which will take in the input of the sample data set or reference data set, and the actual output that it has generated. Okay, LLM given an input query, LLM will generate some output. So that output, the reference data set, these two things will be a part of, it will be passed as input to the evaluators. Then our evaluators will generate a score or some kind of string. Okay, so if you see here, the type of the output of evaluator can be a key. Okay, and the output can be a score or value. Okay, so it can be either a numeric value or it can be a value if it is a categorical. Okay, so so this score or value, basically it will determine the quality of the output that it has generated. So based on that, we can evaluate like if our LLM is performing well or not. Now, in order to generate this sample or reference data set that we just discussed about, where we have some test input and reference outputs for the LLM to refer. In order to generate this, we can obviously first we can generate manually. Okay, we can have some our own set of samples of input and output, just like we did in our Mongo query generation, right, where we had our sample query text and sample MongoDB query. In order to strengthen the dataset more, we cannot just have some limited set of examples, right? In order to strengthen our dataset, we can have user feedback placed in place. So when the users will be interacting with our LLM application, given their query, we'll be generating some output. Then we can take feedback from the user whether that output that was there was satisfactory or not. If it was not satisfactory, we can add that input and output pair to our dataset, mark it like it was a negative result that we generated, right? So our LLM will learn from that, like how to rectify the future interaction with the user, right? Then we can have the LLM feedbacks also, because in some cases, let's say instead of having, I mean, along with having user feedback, we can have we can use LLM to label our chatbot conversation as good or bad outputs. Okay, because in some cases user might rephrase their query or ask the LLM to rephrase the output or try to give some extra insights in order to get the desired output. In those cases, our LLM can learn from that, and it actually inherently and internally it can um, involve that data, include that data set, or include that input output pair in our data set. So that's how we generate the data set for our evaluation engine. Okay, and obviously we can have some synthetic data. Once we have some few examples, we can artificially generate some samples data. We can ask LLM again to generate some sample data for us once we have some practical real life examples with us. All right, so that's how the evaluation concepts work actually. And as I told, I'll create a code examples on how to evaluate LLM application. So that was about the evaluation concept of LangChain. We'll discuss all these things in detail when we'll be doing a practical application of this. Okay, then the final concept is the testing. Okay, so as we know, every framework that you use, it has some testing framework associated with it, right? So similarly in LangChain also, we have frameworks for doing unit test and integration test. So unit test is where we test our individual functions, just like we do unit test in other kind of frameworks also. Let's say Node.js, you do unit test. In unit test, you test the desired input and output of individual functions, right? Similarly, we can do that here as well. For example, we have a function like this, let's say, where we have a message, and then we have the result which will convert this message to OpenAI message, and the expected output is that it should be like this, right? We had seen in OpenAI, the message format is like this, role and this kind of in JSON object to give the OpenAI message. So this is what this is doing, that kind of simple comparison, and we are doing a set. So this is how you write test cases for individual functions. So that is what unit testing is about. And in integration test, what you can do, in integration test you can multiple functions at once. For example, you want to test one tool which we have, right, which does a multiplication for us, and we want to invoke that tool. Okay, let's say we want to test this tool. Okay, parrot multiply tool, and there we want to invoke it with, let's say, two parameters. So parrot multiply tool is just a simple tool which multiplies two numbers, and when we invoke that, we get the result, and then we can actually write test cases with this asset block, and we can do integration testing as well. Okay, I have not tried out this testing frameworks of LangChain yet. I will definitely try it and share you some practical insights and my experience about how to use these testing frameworks. We'll see some real life code examples as well. Okay, yeah, that was about the four concepts of today, which is quite helpful in debugging your LLM application. And that marks the end to our LangChain crash course series. And I hope I was able to make you understand of all these concepts, around 15 to 20 concepts we learned, with code examples. I hope you were able to get a good hold of this framework. Okay, maybe you might not have understood all of them completely, but still, if you like this playlist, please share it with your friends who is trying to learn who is trying to learn LLMs. So you will definitely like it. So if you like this video and like this playlist, please hit the thumbs up button of this video and subscribe to my channel. We are targeting to reach 2200 subscribers by the end of this month. So keep supporting. If you have any questions, just ask me in the comment section, or you can have discussion around the topics there. So thank you for watching this video, and I'll see you in the next one. Thank you.